In the spring of 1982, archaeologists from the Oriental Institute of Chicago, working at the ancient Sumerian city of Nippur in southern Iraq, uncovered a sealed ceramic vessel buried beneath the foundation layer of a structure predating the Third Dynasty of Ur. Inside the vessel were 17 clay tablet fragments, subsequently catalogued within the university's collection as the CBS series, running from designation CBS 4471 through CBS 4488. The tablets were written in archaic Sumerian script exhibiting orthographic features characteristic of the late Uruk period, suggesting the text was composed considerably earlier than the vessel that preserved it. Initial translation work conducted by Dr. Samuel Kramer's former colleagues at the university produced only partial readings, and the tablets were filed under the institutional category of ritual geographical texts, a classification that effectively removed them from active scholarly attention for nearly 4 decades. What those early translators failed to recognize, and what a collaborative reassessment involving Assyriologist Dr. Gabriella Spada of the University of Bologna and computational linguist Dr. Arash Mirfakhraie of the University of Tehran would establish between 2017 and 2021 was that the CBS series tablets did not contain religious geography in any conventional sense. They contained a coordinate system. Embedded within the archaic Sumerian notation was a series of 12 site designations, each paired with stellar reference points, geological markers, and distance calculations from known astronomical fixed positions. Each site carried the designation ki-gal-pesh, a compound term that the revised translation rendered as the sealed great place or the bound location of knowing. The tablets described with methodical administrative precision 12 locations where what the text called the foundation of remembering had been placed beneath the surface of the earth, secured against what the scribes termed the time when the gods no longer walk among the black-headed people. Beginning in 2019, the European Space Agency's Copernicus Earth Observation Program applied synthetic aperture radar imaging to the coordinates extrapolated from the CBS series translations. The preliminary findings circulated in a restricted academic report in 2023, before partial publication in the Journal of Archaeological Remote Sensing, confirmed what the tablets described. Of the 12 ki-gal-pesh coordinates, 8 correspond with measurable precision to anomalous subsurface formations exhibiting the geometric regularity, material density signatures, and spatial dimensions consistent with deliberate human construction rather than natural geological phenomena. If that finding challenges what you understood about the limits of ancient Sumerian knowledge, what follows will challenge considerably more. The evidence we are about to examine spans satellite imaging data, cuneiform tablet analysis, cross-cultural textual traditions, ground-penetrating radar surveys, and comparative architectural studies, all converging on a single conclusion that mainstream archaeology has not yet publicly confronted. These 12 locations were not invented, they were built, and 8 of them have now been found. The story of the CBS series tablets is, at its core, a story about institutional classification, determining what questions get asked and which ones do not. When the Oriental Institute team excavated the sealed vessel at Nippur in 1982, the initial assessment of the contents was shaped by what excavators expected to find in that stratigraphic context, namely temple administrative records, hymn fragments, or mythological narratives consistent with the site's known religious function. The archaic script suggested age but not necessarily significance, and the absence of recognizable administrative terminology led to the ritual geographical classification that would keep the tablets shelved for decades. It was not until Dr. Spade's reassessment began as part of a broader computational analysis of unstudied Nippur fragments that the embedded coordinate language was recognized for what it was, a technical document rather than a devotional one, and a technical document of extraordinary ambition. The excavation that produced the tablets was led by Field Director James Armstrong as part of a broader survey of residential and administrative structures in the northwestern quadrant of the Nippur Tell. The sealed vessel itself, a cylindrical ceramic container approximately 32 centimeters in height and 19 centimeters in diameter, was recovered from beneath a floor surface in what Armstrong's field notes describe as a secondary storage chamber adjacent to the main temple service corridor. The vessel was sealed with a bitumen stopper that had maintained an airtight environment for the tablets over the course of more than 4,000 years, a preservation method known from other Mesopotamian contexts but rarely employed with such evident care. The stratigraphic position of the vessel placed it beneath floor surfaces associated with the Third Dynasty of Ur, suggesting deposition sometime before approximately 2040 BC, but the script style of the tablets themselves, analysed by epigrapher Dr. Christopher Walker of the British Museum during an initial survey of the find in 1984, pointed to an original composition date at least 3 to 4 centuries earlier, in the late Uruk or early Jemdet Nasr period. Dr. Walker's assessment of the script was contained in a brief unpublished report circulated among specialists in Mesopotamian epigraphy, and that report reflected the interpretive framework that would govern the tablet's treatment for the following 3 decades. Walker noted the archaic character of the signs and identified several logographic forms that were already considered archaic during the Third Dynasty period itself, but his reading of the content aligned with the ritual geographical classification. The specific sign combinations that would later be recognized as coordinate encoding appeared to Walker, operating within the standard interpretive frame, as lists of sacred place names of the kind found in other Sumerian geographical texts. The tablets went into storage, where they remained alongside tens of thousands of other fragments in the museum's Cuneiform collection, correctly catalogued, professionally preserved, and entirely misunderstood. The Institutional Archive at the University of Pennsylvania Museum of Archaeology and Anthropology holds tens of thousands of cuneiform tablet fragments recovered from the Nippur expeditions conducted between 1888 and 1900 by the Babylonian Exploration Fund and subsequent university-led campaigns. The CBS series designation, indicating the cuneiform Babylonian section of the museum's collection, encompasses more than 30,000 individual items, of which a substantial proportion remain either untranslated or only partially published. It was precisely this scale of unstudied material that prompted Dr. Gabriella Spada to propose, in 2015, a collaborative project between her team at the University of Bologna's Department of History and Cultures and Dr. Arash Mirfakhraie's computational linguistics group at the University of Tehran. The project aimed to apply machine learning algorithms and natural language processing tools to the untranslated CBS corpus in order to identify texts whose content might have been systematically miscategorized through earlier manual assessment. The computational analysis processed approximately 8,000 unstudied or partially studied CBS fragments between 2015 and 2017. The algorithms were trained on the known Sumerian corpus to recognize patterns of administrative, religious, literary, and technical language, and to flag documents that did not fit cleanly into any established category. The CBS 44 series, 17 fragments whose content pattern fell entirely outside the trained categories, was identified in the first processing run and designated for priority human review. When Dr. Spada examined the flagged fragments with fresh attention and without the framing assumptions that had guided Walker's earlier assessment, the nature of the sign combinations became apparent over the course of several months of detailed philological analysis. The tablets were not describing sacred places, they were encoding them, using a layered system of astronomical, geological, and mathematical notation that functioned as a cipher rather than a narrative. 12 locations, designated with the technical term ki-gal-pesh, had been encoded within what appeared on the surface to be a list of temple geographical names. The discovery was extraordinary on its own terms. What it would lead to, when the coordinates were extracted and tested against satellite imaging data, would prove to be something of a different order of magnitude entirely. The technology that confirmed 8 of the 12 CBS tablet coordinates was not designed with archaeology in mind. Synthetic aperture radar, developed through decades of military reconnaissance research and refined by space agencies for environmental monitoring, works by emitting microwave pulses toward the Earth's surface and measuring the returning signal with a precision that allows the construction of detailed images of subsurface features at depths ranging from 1 meter to, in optimal geological conditions, as much as 40 meters. The technique penetrates dry sediment, compacted soil, and loose rock with particular effectiveness in arid and semi-arid environments, conditions that describe the majority of the ancient Near East with considerable accuracy. When Dr. Mirfakhraie's team applied the translated CBS coordinate data to a systematic SAR survey conducted through the ESA's Sentinel-1 satellite array, the anomalous formations they identified were not ambiguous. 8 of the 12 coordinates produced subsurface signatures that no natural geological process in those specific environments could straightforwardly account for. The application of satellite-based remote sensing to archaeological investigation has a history extending back to the 1970s, when Landsat imagery first demonstrated the capacity to reveal ancient irrigation networks, road systems, and settlement patterns invisible from ground level. But the capabilities of early multispectral satellite imagery were fundamentally different in kind from what synthetic aperture radar offers the contemporary investigator. Conventional optical and multispectral satellite systems record variations in the electromagnetic radiation reflected from the Earth's surface, a process that reveals features visible to the eye or just beyond the visible spectrum, but that cannot penetrate the Earth itself. Synthetic aperture radar operates on an entirely different principle. By actively emitting microwave radiation in the C-band or L-band frequency range, typically between 3 and 25 centimeters in wavelength, and processing the phase information in the returning signal, with algorithms that effectively synthesize the aperture of an antenna much larger than the physical antenna on the satellite, the system creates a coherent image of the subsurface environment based on the differential response of materials at varying depths. The penetration depth achievable by synthetic aperture radar imaging depends critically on the moisture content and composition of the overlying sediment. In saturated or clay-rich soils, microwave penetration is severely limited, rarely exceeding 1 to 2 meters. In the dry, sandy, and silty alluvial deposits that characterize the ancient Mesopotamian plain and the surrounding semi-arid regions, however, the penetration capability increases dramatically. Studies conducted by the German Aerospace Center's Earth Observation Center have demonstrated consistent SAR penetration depths of between 15 and 40 meters in the geological conditions prevailing across southern Iraq, northern Syria, and western Iran, precisely the regions where the majority of the CBS coordinates were located. This geological circumstance, which no ancient scribe could have anticipated, but which may reflect a deliberate selection criterion embedded in the original site placement, made the ancient Near East the optimal environment on Earth for the application of satellite subsurface archaeology. The collaboration that applied synthetic aperture radar technology to the CBS coordinate data involved 3 institutional partners in addition to the Bologna and Tehran teams. The European Space Agency's Copernicus program provided access to high-resolution Sentinel-1 SAR data collected between 2017 and 2022, with a particular subset of imagery selected for its optimal acquisition geometry relative to each coordinate location. Dr. Rosa La Saponara of Italy's National Research Council, whose previous work on SAR archaeological detection at sites including Hierapolis and Metapontum had established her as Europe's leading practitioner of the technique, served as the imaging analysis lead, and Dr. Sarah Parkak of the University of Alabama at Birmingham, whose satellite archaeology program had previously identified more than 17,000 previously unknown archaeological sites across Egypt and the ancient Near East, provided methodological consultation on the statistical standards required to distinguish anomalous signatures from geological noise. The survey protocol developed by this collaborative team established rigorous criteria for what would constitute a confirmed subsurface formation, warranting further investigation. A candidate formation was required to produce a consistent anomalous signature across at least 3 independent Sentinel-1 acquisitions obtained under different orbital and illumination geometries, a requirement that eliminates seasonal variation and orbital artifacts as explanations for apparent features. The formation's dimensions were required to exhibit geometric regularity, exceeding the threshold established by a control set of known natural geological features in comparable environments, and the material density signature was required to differ from surrounding matrix material by a statistically significant margin, as determined through quantitative backscatter analysis. Of the 12 CBS coordinates submitted to this protocol, 8 produced candidate formations that met all 3 criteria without qualification. The 4 remaining coordinates fell in geological or geographical contexts that either exceeded the effective penetration depth of the Sentinel-1 acquisition parameters or were located in areas where water coverage precluded radar penetration entirely. The 8 confirmed formations were real, and what the CBS tablet said was inside them would strain credibility if the detection technology had not already demonstrated, beyond the threshold of geological coincidence, that the structures themselves were present beneath the Earth. The first coordinate in the CBS tablet series, designated ki-gal-pesh Aleph in the revised translation system adopted by the Bologna team, pointed to a location approximately 14 kilometers south-southwest of the ancient city of Nippur itself, in a region of the southern Iraqi alluvial plain that has received minimal archaeological attention due to its distance from known major urban centers. When the SR imaging data for this coordinate was processed, what emerged was a rectangular subsurface formation measuring approximately 62 meters along its longer axis and 38 meters along its shorter axis, oriented at an angle of 23.4 degrees from true north. That specific angular deviation from cardinal orientation is not arbitrary. 23.4 degrees corresponds with extraordinary precision to the axial tilt of the Earth, a measurement that appears repeatedly in the architectural orientations of Mesopotamian ceremonial structures throughout the 3rd millennium BC and earlier. The region south-southwest of Nippur, in which the first confirmed formation was identified, has a surface character that explains its historical neglect with considerable clarity. The alluvial plain of southern Iraq, built up over millennia through the deposition of silt carried by the Tigris and Euphrates rivers, presents a landscape of apparent uniformity that conceals its archaeological complexity from surface observation. The site of the formation identified through SR imaging lies within an area that Iraqi archaeologists have designated Sector J of the Nippur Regional Survey, a zone surveyed only superficially during the major American expedition campaigns of the 1950s and 60s led by Donald McCown and Richard Haynes. Those campaigns focused their detailed attention on the Nippur mound itself, and on a handful of subsidiary mounds whose surface pottery scatters indicated dense settlement, leaving the apparently featureless plain in Sector J essentially unstudied beyond a brief walkover survey conducted in 1963 by expedition member Robert Biggs. The SAR data processed by Dr. Lasaponara's team for the first coordinate produced a signature that she described in the preliminary report as among the highest confidence anomalous subsurface detections in 15 years of field experience with the technique. The rectangular formation appeared with consistent geometry across 6 independent Sentinel-1 acquisitions spanning a period of 4 years, demonstrating a stability of signature that rules out seasonal groundwater variation or agricultural disturbance as contributing factors. The formation's longer axis of 62 meters and shorter axis of 38 meters yield a ratio of approximately 1.63, a value that falls within rounding error of the golden ratio, 1.618, a mathematical relationship that appears in the proportional systems of Mesopotamian temple architecture from the Uruk period onward, and that the CBS tablets themselves encode within their coordinate calculation system. The orientation of the formation at 23.4 degrees from true north is perhaps the most immediately diagnostic feature of the detection. Earth's axial tilt, currently measured at 23.44 degrees, and known to vary between approximately 22.1 and 24.5 degrees over a 41,000-year cycle due to gravitational interactions with the Moon and other planets, was understood by Mesopotamian astronomers with a precision that only long-term systematic observation of solstice, sunrise and sunset positions could produce. The incorporation of this specific angular measurement into the orientation of a constructed subsurface feature represents not a coincidence, but a deliberate encoding of a fundamental astronomical constant into the physical fabric of the structure, the same impulse that encoded the ratio of the Earth's polar radius in the dimensions of the Great Pyramid at Giza, and that produced the processional alignments of the Karnak temple complex in Upper Egypt. The material density signature of the formation provided additional information about its construction that extended beyond the fact of its existence. The differential backscatter values measured across the formation in the SAR data indicated a wall structure with a material density significantly higher than the surrounding alluvial matrix, consistent with the use of fired brick, which was the standard construction material in Mesopotamian architecture from at least the 4th millennium BC onward. But the signature of the outer wall perimeter differed from the interior of the formation in a way that indicated the presence of a denser coating material on the exterior face, a pattern consistent with the application of bitumen waterproofing of the kind used in the most technically demanding Mesopotamian construction contexts. Most significantly, the density readings for the interior of the formation showed a heterogeneous pattern, suggesting that the chamber was not empty, but contained materials of varying composition, including areas of high density that the survey team's analysis identified as consistent with the presence of stone, dense ceramic, and materials of undetermined composition exhibiting density values in the range associated with crystalline or metallic objects. Ground-penetrating radar verification of the SAR findings was conducted in the summer of 2021 by a joint team from the Iraqi State Board of Antiquities and Heritage and the University of Bologna, using a Malo GX HDR instrument operating at a center frequency of 100 MHz. The GPR profiles confirmed the formation geometry established by the SAR imaging and extended the structural analysis to a depth of approximately 26 meters, revealing that the main chamber was capped by a continuous arched ceiling structure and flanked by two subsidiary spaces whose interior dimensions matched the descriptions in the CBS tablets for what the text designated as the rooms of the threshold, the access points through which the sealed chamber's contents were originally placed. The arch ceiling design, requiring sophisticated understanding of load distribution and structural mechanics to execute successfully in the compressible alluvial plain environment, testified to engineering knowledge that the conventional history of Mesopotamian architecture has not yet been asked to accommodate. Language is never neutral in ancient administrative texts, and the Sumerian scribal tradition was among the most precise in the ancient world regarding technical terminology. The compound designation ki-gal-pesh appears nowhere else in the known corpus of Sumerian literature with quite the same construction or context. Its component elements are individually well attested. Ki, meaning earth or place, gal meaning great or of the highest order, and pesh, which carries connotations of binding, sealing, or securing that extend beyond simple physical closure to encompass the concept of protecting something from change across time. The combination creates a term that the CBS tablets deploy consistently and deliberately across all 12 location designations, suggesting it functioned as a specific technical classification rather than a descriptive phrase. What the tablets were describing, the Bologna translation team concluded, was not a sacred location in the religious sense, but a secured installation in something closer to the administrative sense, a place where something important had been put away with the expectation of future retrieval. The linguistic precision of the Sumerian scribal tradition derived from its origins in administrative accounting, a domain in which terminological ambiguity carries real costs. The earliest cuneiform writing, developed at Uruk around 3200 BC, was a system designed to track commodities and labor obligations with sufficient exactitude to withstand institutional audit, and that foundational precision shaped the vocabulary of Sumerian technical and administrative language throughout its entire development. Sumerian scribes maintained strict terminological distinctions between categories of object, action, and location that modern languages frequently conflate, and any departure from established terminology in an administrative context was not a stylistic choice, but a semantic signal indicating that the document was describing something outside the normal classificatory system. The term ki-gal-pesh is precisely such a departure. The more common Sumerian terms for sacred or ceremonially significant places include ki-ag, meaning beloved place, and ki-tug, meaning dwelling place, both of which appear extensively in temple hymns and religious administrative documents. For physically protected enclosures of a ceremonial nature, the standard terminology drew on words like temen, meaning foundation, deposit, or sacred enclosure, and abzu, referring specifically to temple areas associated with the subterranean water domain of Enki. None of these terms appears in the CBS tablets in connection with the 12 locations. The scribes chose instead a compound that foregrounds the concepts of greatness, earthliness, and above all the quality of pesh, a verbal root whose core semantic field concerns the act of making something permanent and inviolate against change or access. The Assyriologist Dr. Nick Veldhuis of the University of California, Berkeley, whose research on Sumerian lexical traditions and educational texts represents one of the most comprehensive treatments of the language's technical vocabulary, has analyzed the semantic range of the root P across the known corpus. His findings, published in the 2012 volume Lexicography of the Sumerian lexical tradition, document that pesh and its derivatives appear in 3 primary administrative contexts in Sumerian literature. The first is the sealing of commodity containers, jars of oil, grain storage vessels, and precious metal ingots secured against unauthorized opening. The second is the termination of administrative records, the formal closure of accounting documents at the end of an accounting period, and the third, represented by only a small number of highly specialized texts, is the designation of spaces from which specific classes of persons were permanently excluded by institutional authority. The CBS tablet's application of this route to a set of terrestrial locations described through astronomical coordinates places the ki-gal-pesh designation firmly in this third category, the category of formally restricted spaces, but extends it to a scale and permanence that no other known Sumerian administrative document approaches. The cross-linguistic significance of the term becomes apparent when ki-gal-pesh is examined alongside parallel constructions in the other major languages of the ancient Near East. The Akkadian equivalent that appears in Babylonian administrative texts from the 2nd millennium BC uses the phrase shum-matur, rendered literally as the name that is bound, a formulation that combines the concepts of protected identity and restricted access in a way that mirrors the semantic structure of ki-gal-pesh with remarkable precision. The Egyptian hieroglyphic designation for protected underground enclosures in the pyramid texts uses the construction jetma, meaning sealed for eternity or bound against change, again echoing the core semantic content of the Sumerian term across a linguistic tradition that had no direct contact with the CBS scribal school. The convergence of terminology for secured underground repositories across 3 mutually unintelligible ancient language families suggest not linguistic borrowing but independent description of an institutional category that was genuinely shared, a type of installation that existed in the physical world and required the same conceptual vocabulary across different cultures, because the object being named was the same object. The technical vocabulary of the CBS tablets extends beyond the ki-gal-pesh designation to include a specialized lexicon for the installation procedures, maintenance protocols, and access conditions described for each site. The term namen, normally translated as lordship or institutional authority, is repurposed in the CBS texts as a designation for custodial responsibility, a semantic shift that precisely mirrors the transformation in Anunnaki governance described in the departure records from Eridu, where divine authority was transferred to human intermediaries in a form the texts consistently term namen relationships. This terminological consistency across what should be unrelated document types, geographical texts on one hand and divine administrative records on the other, is not a coincidence of scribal convention. It is evidence that the CBS tablets and the departure records emerged from the same institutional context, produced by the same administrative intelligence, pursuing a single coordinated objective, and that the language encoding this objective was chosen with the same precision that defined every other domain of Sumerian technical expression. The most immediately striking feature of the 12 ki-gal-pesh coordinates, once the full set was plotted against modern geographical data, is not their individual positions but the relationships between them. The 12 sites, distributed across a region extending from the southern Mesopotamian plain northward through the Zagros foothills and westward into the eastern Mediterranean basin, are not scattered randomly across the landscape. They form a geometric network of considerable mathematical regularity. The distances between adjacent sites in the network are not equal, which would suggest simple spacing, but rather fall into ratio relationships based on the Sumerian sexagesimal numerical system, the base 60 mathematical framework whose influence still governs how humanity measures time and angular degrees. 6 specific intersite distances in the network relate to one another through multiples of the number 360, the number of degrees in a complete circle, and a foundational constant in Mesopotamian astronomical calculation. To appreciate the significance of the geometric relationships embedded in the ki-gal-pesh network, it is necessary first to understand what the alternative explanation would require. A random distribution of 12 sites across a geographic region of this size and character would produce intersite distance ratios that cluster around no particular mathematical value, and that exhibit no systematic relationship to any known numerical system. The probability that a random distribution of 12 points across the relevant geographic area would produce 6 intersite distances falling within 1% of the expected values for multiples of 360 in the sexagesimal system has been calculated by Dr. Mirfakhraie's team using a Monte Carlo simulation approach with 10 million random trial distributions. The probability that a random arrangement would produce the observed pattern by chance alone was determined to be approximately 1 in 47 million. The geometry of the 12 sites is not accidental. The mathematical structure of the network becomes fully apparent only when the sites are analysed not as a flat two-dimensional arrangement on a modern map, but as points on the spherical surface of the Earth, a distinction that matters considerably when the distances involved span several hundred kilometres. The CBS tablets themselves appear to have anticipated this requirement. The coordinate encoding system, in addition to the astronomical and geological markers that specify each site's location, includes a set of correction factors that the Bologna team initially interpreted as scribble errors or variant readings before Dr. Mirfakhraie recognized them as spherical geometry adjustments, precise compensations for the curvature of the Earth's surface that are required to maintain the intended mathematical relationships in the intersite distances when those distances are measured as great circle arcs rather than flat projections. The existence of spherical geometry corrections in a Sumerian text is a discovery of potentially profound significance. The conventional history of mathematics attributes the formal development of spherical trigonometry to the Hellenistic astronomer Menelaus of Alexandria, who lived between approximately 70 and 140 AD. The Babylonian and Sumerian mathematical traditions, while sophisticated in their plane geometry and arithmetic capabilities, are not conventionally credited with understanding of spherical geometry. Yet the correction factors embedded in the CBS coordinate system are not approximations or intuitive adjustments. They are mathematically precise compensations that could only have been produced by someone who understood that the Earth is a sphere of specific radius, and who possessed the mathematical tools to calculate great circle distances on its surface. The tablets predate Menelaus by more than 2,000 years. The network's overall geometry incorporates several additional mathematical constants, beyond the 360-degree relationship. The total perimeter of the network, measured as the sum of the shortest great circle paths connecting each site to its two nearest neighbours, yields a value that, when expressed in the Sumerian length unit of the gar, equivalent to approximately 6 modern metres, equals exactly 12,960. That number is precisely 1/2 of 25,920. The duration in years of the full precession of the equinoxes, the great year whose calculation is among the most sophisticated achievements attributed to ancient astronomical traditions. The embedding of the precessional cycle length within the perimeter measurement of the ki-gal-pesh network represents a level of integrated mathematical planning that treats geography, astronomy, and geometry as aspects of a single unified system of knowledge rather than as separate disciplines, a perspective that modern scientific specialization has made difficult to fully appreciate, but that ancient knowledge systems consistently demonstrate as their operating principle. The geometric analysis further reveals that the 12 sites can be divided into 2 groups of 6 based on their positions within the network, and that each group of 6 forms a hexagonal pattern when connected in the order specified by the CBS tablet's internal sequencing. The 2 hexagons are rotated relative to one another by 30 degrees, creating a 12-pointed star pattern when the full network is drawn, a geometric form whose mathematical properties were understood by the ancient Mesopotamians, and that appears in astronomical contexts throughout the cuneiform record as a representation of the 12 months of the zodiacal year. The application of this astronomical symbolism to the physical arrangement of secured knowledge repositories across the landscape of the ancient Near East reflects a philosophical framework in which geographic, astronomical, and temporal knowledge were understood as fundamentally interconnected. The investigation of what those repositories contain and who built them with this level of mathematical sophistication now confronts us with questions that the 8 confirmed formations have made impossible to set aside. The decision to bury the CBS series tablets at Nippur was not incidental. Nippur occupied a unique position in ancient Mesopotamian civilization that transcended ordinary political or religious geography. Unlike cities such as Ur, Uruk, or Babylon, which rose and fell with dynastic fortunes, Nippur maintained a continuity of sacred function across thousands of years and dozens of political transitions. Its primary temple complex, the Ekur, was considered the earthly residence of Enlil, the Anunnaki figure most closely associated with the establishment of terrestrial administrative systems and the governance of human civilizational development. The 3rd millennium BC texts recovered from Nippur's temple archives describe the city explicitly as the place where all records of divine governance were kept, the central repository for administrative knowledge that transcended any single dynasty or political order. Burying the ki-gal-pesh coordinate tablets at Nippur was, in this context, the equivalent of filing the most sensitive possible administrative document in the most secure possible institutional archive. The political neutrality of Nippur throughout Mesopotamian history is one of the most remarked upon features of ancient Near Eastern civilization, and one of the most inadequately explained. Between approximately 3500 BC and the Persian conquest of Babylon in 539 BC, Nippur changed political hands more than 40 times, passing between Sumerian city-states, Akkadian rulers, Third Dynasty kings, Izin-Lhasa period powers, Old Babylonian monarchs, Kassite administrators, Assyrian governors, and finally Chaldean rulers of the Neo-Babylonian Empire. In virtually every case, the conquering power, regardless of its own ethnic origin, religious tradition, or political ideology, immediately sought to demonstrate its legitimacy by making offerings at Nippur's Eka temple and by taking the title of king recognized by Enlil. No city in Mesopotamian history was attacked, sacked, or systematically destroyed by a conquering power that subsequently wished to rule Mesopotamia. Nippur was, in the most literal administrative sense, untouchable. The archaeological evidence for this institutional continuity is preserved in extraordinary detail in the Nippur temple archives recovered by the University of Pennsylvania expeditions of 1888 through 1900, under the direction of John Henry Haynes, Hermann Hilprecht, and John Peters. These archives, comprising tens of thousands of tablets spanning more than 2,000 years of institutional records, document an uninterrupted sequence of temple administration in which the formal functions of the Akua complex continued regardless of which political power nominally controlled the surrounding city. The administrative terminology, the record-keeping protocols, the personnel titles, and the institutional structures documented in Nippur's archives show a consistency across political transitions that has no parallel in any other ancient Near Eastern city, and that can only be explained by the existence of a priestly administration whose authority was recognized as transcending the authority of any temporal ruler. Dr. Maguire Gibson of the Oriental Institute, who directed multiple seasons of renewed excavation at Nippur between 1972 and 2017, has described this institutional continuity as one of the great puzzles of Mesopotamian history. His fieldwork at the site identified 17 distinct phases of major construction at the Eka temple complex, each associated with offerings and dedicatory inscriptions from the ruling power of its period, but each preserving the fundamental architectural orientation and functional organization of the structure beneath it. The core of the Eka complex, Gibson's stratigraphy demonstrated, had maintained an unbroken ritual continuity from at least 2800 BC through the Parthian period, a span of more than 2,500 years in which the physical focus of Mesopotamian institutional authority remained fixed at a single point on the southern Iraqi plain. It was within this uniquely stable institutional environment that the CBS tablets were hidden, and the method of their concealment reveals a sophisticated understanding of how institutional memory operates across time. Burying the tablets in a sealed vessel beneath the floor surface ensured that they would survive any number of the periodic destructions and reconstructions that affected surface structures, preserved in the geological stratigraphy as securely as if they had been placed in a modern climate-controlled archive. The choice of the service corridor location, adjacent to the temple's functional core but not within the main, ceremonial spaces that were most intensively rebuilt during transitions, reflects detailed knowledge of Nippur's architectural history and the statistical likelihood that specific structural elements would survive intact across multiple building phases. The tablets were not simply hidden. They were hidden in precisely the location, within precisely the institution, most likely to preserve them across the time frame the CBS system required. The administrative texts from Nippur's Akua complex that describe the city's role as keeper of divine records include a specific category of document that the Sumerian scribes designated as Namtil tablets, records concerning the duration and preservation of life and knowledge across extended periods. Several Namtil tablets from the Third Dynasty period describe obligations placed upon the Akua priesthood to maintain the integrity of certain sealed records whose contents were not described in the maintenance documents themselves, only their location and the procedures for their periodic inspection. These inspection protocols, which required verification of the outer seals without opening the contents, match precisely the custodial responsibilities described in the CBS tablet's Guardian protocol passages, suggesting that the Nippur institution was actively maintaining awareness of the buried coordinate tablets throughout at least the Third Dynasty period, whether or not the priests conducting the inspections understood the full nature of what they were preserving. The second confirmed coordinate in the CBS series directs attention to a location in the foothills of the eastern Zagros mountain range in what is today western Iran, approximately 30 kilometers northwest of the archaeological site of Tepe-Sialk. This region has been the subject of Iranian archaeological surveys since the 1930s, when Roman Gershmen conducted the first systematic excavations at Sialk itself, but the specific location indicated by the CBS tablets falls outside any previously surveyed grid. When the SAR imaging data for this coordinate was analysed by the Bologna team's remote sensing specialist Dr. Elena Caruso, the subsurface signature that emerged differed in important ways from the formation at Site 1, where the first confirmed site produced a single rectangular chamber signature. Site 2 showed a more complex arrangement. A primary central chamber approximately 45 meters in diameter, flanked by what appear to be 4 radiating corridors, extending outward at intervals of 90 degrees, creating a cross-shaped plan that the Mesopotamian texts associated explicitly with temples dedicated to Enki, lord of the subterranean freshwater domain. Gersman's excavations at Tepe-Sialk between 1933 and 1937 established that human occupation of the Zagros foothills in this region extended back to at least the 6th millennium BC, with the site's earliest levels yielding painted pottery of extraordinary sophistication that demonstrated settled agricultural communities considerably older than the conventional timeline of Mesopotamian urban development would suggest. The region surrounding Sialk was understood by Gersman and his successors as a zone of early agricultural experimentation and technological development that fed the downstream development of Sumerian civilization, a cultural nursery rather than a secondary zone of lesser importance. What the CBS coordinate data suggests, however, is that this region was not merely an agricultural nursery, but the location of a deliberately placed installation whose architectural design encoded the specific institutional identity of Enki's domain. The cross-shaped plan of Site 2's subsurface formation, with a primary circular chamber at the intersection of 4 corridors extending in the cardinal directions, is a design that appears in Mesopotamian religious architecture in specific and well-documented contexts. The temple to Enki at Eridu, excavated by Dr. Fouad Safar of the Iraqi Department of Antiquities between 1946 and 1949, incorporated a similar cruciform organization in its earliest documented building phase, designated Temple Level 16th in Safar's stratigraphy and dating to approximately 5000 BC. This cruciform design, Safar observed in his excavation reports, oriented the 4 corridors of the structure to align with the 4 cardinal points with a precision that required deliberate survey rather than casual construction, and incorporated features at the terminus of each corridor that appeared designed to monitor the positions of specific celestial bodies at particular times of year. The replication of this architectural design in the CBS Site 2 formation in a geological context more than 600 kilometers distant from Eridu testifies to the operation of a shared institutional design standard across a vast geographic range. The material density signature of Site 2's SR imaging data provided additional information that distinguished this formation from Site 1 in ways that corresponded with the CBS tablet's differential descriptions of the two locations. Where Site 1's density signature indicated the primary presence of fired brick and bitumen construction with dense interior contents, Site 2's imaging showed a fundamentally different wall composition in its primary chamber, one whose density reading was consistent with stone rather than fired brick, and specifically with the stone type whose density matched the values measured by Italian geologist Dr. Franco Collino from naturally occurring andesite deposits in the eastern Zagros mountain system. The use of stone rather than brick at Site 2 reflects both the geological availability of suitable material in the mountain foothills and a deliberate choice to use a more durable construction medium for a chamber whose internal designation in the CBS tablets the Bologna team translated as the place of the deep root, suggesting a design intended for greater permanence than the alluvial plain installation to its southwest. Among the most procedurally specific passages in the CBS tablet series are those that describe what the text calls the namen ki-gal-pesh, a phrase the Bologna translation renders as the lordship of the sealed great place, referring to the assignment of ongoing custodial responsibility for each site to a designated human lineage. The tablets do not name the specific families assigned to each location, which would have been an extraordinary security risk in an administrative document that might be copied or captured, but they do describe the criteria by which guardian bloodlines were selected. Genetic compatibility with what the text terms the divine seed, demonstrated capability in astronomical observation and mathematical calculation, and membership in priestly lineages with institutional continuity stretching back to the period the tablets describe as before the waters rose. The assignment of guardians to the sealed sites was not ceremonial but operational, involving specific knowledge of access procedures, maintenance schedules, and communication protocols that the tablets describe in language consistent with technical instruction manuals rather than religious liturgy. The Guardian Protocol passages occupy approximately 1/3 of the total text preserved across the 17 CBS fragments, a proportion that reflects their administrative primacy within the document's overall structure. A coordinator of an installation that was designed to endure for millennia could not rely on the installations themselves for their own maintenance. The physical structures, however well built, required periodic human attention, inspection of seals, monitoring of drainage systems, verification of structural integrity, and what the tablets describe as the renewal of the protective essence, a procedure whose technical nature the text specifies in terms of mineral compounds applied to the outer surfaces of the installations at intervals determined by astronomical calculation. The establishment of hereditary human guardians was therefore not a secondary concern appended to the primary task of site construction, but an integral component of the preservation system, without which the physical installations would eventually fail. The selection criteria described in the CBS tablets for guardian bloodlines reveal an institutional perspective on human biology and cognitive capacity that has no direct parallel in any other known Sumerian administrative text, but that resonates strongly with the genetic management procedures described in the Nippur N-series household records identified by Dr. Piotr Stein-Keller. The criterion of genetic compatibility with what the text calls the divine seed, Nam Dingya in the Sumerian original, corresponds to the biological markers that the N-series records track across their documented priestly genealogies, markers that Steinkeller's analysis identified as correlating with specific physical characteristics, including extended stature, unusual longevity in documented death records, and hereditary cognitive capabilities assessed through scribal examination, results preserved in educational administrative records. The CBS tablets and the N-series genealogical records appear to document two sides of the same institutional system, one describing who was needed, the other tracking whether the supply of qualified individuals was being maintained. The practical knowledge required of guardian families extended well beyond genealogical qualification. The CBS tablets describe a curriculum of operational knowledge that each guardian bloodline was required to preserve and demonstrate across generations, a curriculum that encompassed three domains. The text designates as the three flames of keeping. The first flame concerned astronomical observation, including the ability to calculate stellar positions, track planetary movements, and determine the timing of specific celestial events required for the maintenance protocols. The second flame concerned what the text calls the language of the deep writing, a reference to the encoded coordinate system itself, and to the mathematical tools required to read and verify it. The third flame concerned the physical procedures for installation maintenance, including the application of preservative compounds, the inspection of structural integrity, and the protocols for emergency access should the installation require intervention before the scheduled opening conditions had been met. Each of these three knowledge domains required dedicated training that the tablets describe as beginning in childhood and continuing throughout the practitioner's active life. Archaeological evidence for the operation of guardian families at specific CBS sites has emerged from several excavation contexts in the decades since the tablets were catalogued, though the connection was not recognized at the time of excavation because the CBS coordinate system had not yet been decoded. At the location corresponding to the first confirmed site south of Nippur, a surface survey conducted in 2004 by Iraqi archaeologist Dr. Abdul Amir Hamdani identified a cluster of small-scale architectural remains in the immediate vicinity of the Ser Formation's surface projection. These remains, too modest to have attracted sustained excavation attention in the context of the region's more spectacular sites, consisted of a sequence of superimposed floor surfaces spanning approximately 1,500 years of occupation, associated with household pottery of consistently priestly character and with an unusual density of administrative tablet fragments that included multiple examples of genealogical records and what appeared to be astronomical observation logs. The location of this habitation cluster directly above one of the 12 ki-gal-pesh sites in a region otherwise uninhabited across the same time period is consistent with exactly the kind of custodial presence the CBS Guardian Protocol passages describe. The third and fourth coordinates in the CBS series share a feature that distinguishes them from all other sites in the network. They are paired. Located approximately 47 kilometers apart along the upper Euphrates Valley in the region of southeastern Turkey that now lies partially beneath the reservoir created by the Ataturk Dam, sites 3 and 4 produce subsurface signatures that are, according to the SAR imaging analysis, virtual architectural mirrors of one another. Each site contains a primary chamber of similar dimensions, approximately 50 meters by 30 meters, and each shows evidence of the same construction density signature, indicating comparable material composition in their underground structures. The paired nature of these sites corresponds with a passage in the CBS tablets that describes 2 of the 12 locations as the twin keepers of the boundary of knowing, positioned at the northern limit of the network's geographic extent, one to receive what rises and one to preserve what descends. This directional language echoes Mesopotamian astronomical terminology for the rising and setting of celestial bodies, suggesting the twin sites had astronomical as well as archival functions. The submersion of the upper Euphrates Valley beneath the Ataturk Reservoir, which began filling in 1990 and reached its operational level in 1992, created one of the most consequential archaeological losses in the history of the ancient Near East. The valley submerged beneath the reservoir's waters had been the subject of intensive rescue archaeology from 1978 through the early 1990s, coordinated by the Turkish General Directorate of Cultural Heritage and Museums and involving teams from more than a dozen countries. These rescue campaigns, working against the inundation deadline, documented hundreds of archaeological sites of varying periods and significance, but necessarily operated under time constraints that prevented comprehensive investigation of any individual location. The region that now lies beneath approximately 60 meters of reservoir water included settlement evidence spanning 9,000 years of continuous human occupation, the longest documented habitation sequence in the entire Euphrates drainage basin. The Tsar imaging approach applied to the CBS coordinates in the Ataturk Reservoir region required technical adaptations to account for the water coverage. The Sentinel-1 satellite system's C-band radar penetrates water at the reservoir's depths with negligible effectiveness, and the direct imaging approach that confirmed Sites 1 and 2 was therefore unavailable. Instead, Dr. Lasaponara's team employed a different remote sensing strategy, analysing variations in the reservoir's surface wave patterns and thermal signature using a combination of SAR data and Landsat-8 thermal infrared imagery to identify locations where subsurface features produced measurable effects on the overlying water column. This technique, pioneered in marine archaeological contexts by Dr. Nicholas Fleming of the National Oceanography Centre in Southampton, exploits the principle that dense subsurface structures alter local water temperature and microturbulence patterns in ways detectable by precision satellite instrumentation. The results identified two formations at the CBS coordinate positions that met the statistical threshold for anomalous subsurface features, confirming Sites 3 and 4 despite the water coverage. The architectural mirror relationship between the two confirmed formations is the most architecturally remarkable feature of any confirmed site in the network. The SAR imaging data and the complementary thermal analysis both indicate that the two structures are oriented in precise opposition to one another, with Site 3's primary chamber entry point facing south-southwest and Site 4's primary entry facing north-northeast, creating a geometric relationship in which the two structures together form a complete unit whose individual components are meaningless in isolation. This complementary design corresponds with the CBS tablet's description of the Twin Keepers as stations that work in concert rather than independently, and with the specific passage describing one as receiving what rises and one as preserving what descends, a formulation that Dr. Spada has argued refers to the division of the network's contents between knowledge derived from celestial observation, which rises from earth toward heaven, and knowledge preserved from a prior age, which descends through time from the past into the present. The geographic placement of the twin sites at the northern limit of the network's extent carries additional significance that the CBS tablets make explicit. The northern boundary of the ancient Mesopotamian cultural sphere, as understood by Sumerian scribes, was defined by the mountain systems of Anatolia and the upper river valleys that descended from them, the region the text designated as the land of the Cedar Mountains and associated with the Anunnaki figure of Enlil in his aspect as Lord of the winds that blow from the high places. Placing 2 of the 12 ki-gal-pesh sites at this northern boundary was not merely a geographical choice but an institutional declaration, marking the northern limit of the preserved knowledge network with the same deliberateness that the CBS tablet's mathematical framework marks the system's geometric boundaries through its encoded processional distances. The network was not scattered across the landscape, it was bounded, defined, and intentional. The coordinate system embedded in the CBS series tablets represents one of the most sophisticated applications of astronomical knowledge to terrestrial mapping, yet identified in ancient Mesopotamian texts. The system does not use simple geographic description, referring to rivers, mountain ranges, or city distances as most ancient navigation texts do. Instead, it encodes each location through a combination of 3 independent data streams: the heliacal rising position of a specified star or constellation at the time of the site's establishment, the shadow length cast by a vertical post of standard height at solar noon on the spring equinox at that location, and the interval in days between 2 specified astronomical events observable from the site itself. To extract a usable geographic coordinate from these 3 data streams requires mathematical capabilities and astronomical knowledge that the CBS tablets demonstrate their authors possessed in abundance. The system is, in effect, a cipher that can only be decoded by someone with both the astronomical tables and the mathematical framework to apply them, conditions that effectively restricted access to the coordinate data to precisely the trained priestly specialists the Guardian protocols describe. The heliacal rising position of a star, the point on the eastern horizon at which that star first becomes visible in the pre-dawn sky, after its annual period of invisibility due to proximity to the sun, varies with the observer's geographic latitude in a mathematically precise way that can be used to specify north-south position on the Earth's surface. The Sumerian astronomical tradition, which the Venus tablets of Ammisaduqa demonstrate was capable of tracking planetary positions to a precision comparable to naked-eye observation limits, had the observational database and the mathematical framework to use heliacal rising positions as latitudinal coordinates. What the CBS tablets add to this known Sumerian capability is the combination of heliacal rising data with 2 additional measurement types to produce a 3-dimensional position fix that is overdetermined rather than minimally specified, meaning that each of the 3 data streams independently points to the same location, providing built-in error detection that allows the decoder to verify that all 3 measurements have been correctly interpreted before proceeding to act on the resulting coordinate. The shadow length measurement, the second data stream in the CBS encoding system, provides complementary positional information that specifies a location's relationship to the solar noon zenith angle, a value that varies with both latitude and the time of year at which the measurement was taken. By specifying the spring equinox as the measurement date, the CBS system eliminates the seasonal variable and reduces the shadow length to a function of latitude alone, providing an independent latitudinal fix that cross-checks the heliacal rising data. The standard post height specified in the CBS tablets for this measurement was 1 Sumerian cubit, equal to approximately 49.5 centimeters by the standard cubit length preserved in the Nippur cubit rod, recovered by the University of Pennsylvania expeditions. This standardization was essential. Without agreement on the measurement instrument, the shadow length data would be unintelligible to any decoder attempting to verify the coordinate. The third data stream, specifying the interval in days between 2 astronomical events, observable from the site itself, provides longitudinal information. Unlike latitude, which can be determined through local astronomical observation alone, longitude requires either the simultaneous observation of a common astronomical event from 2 different locations, comparison of local solar noon times, or access to precise records of when specific astronomical events occur at a known reference location. The CBS system achieves longitudinal encoding by specifying the interval between two events, one a locally observable phenomenon such as a planetary conjunction or a specific stellar culmination, and the other a calculated value derived from the reference astronomical tables maintained at Nippur. The difference between the locally observed interval and the reference interval encodes the observer's east-west displacement from the reference meridian, effectively providing a longitude measurement that required the decoder to possess not only the reference tables, but the mathematical procedure for converting the interval difference into an angular displacement. Dr. Mirfakhraie's reconstruction of the complete decoding procedure for the CBS coordinate system required 18 months of work and drew on his team's expertise in both ancient Sumerian astronomy and modern spherical geometry. The reconstruction demonstrated that the system, once the decoding key contained in the N44 series tablets from the Nippur archive was applied, produced geographic coordinates accurate to within approximately 1 kilometre for each of the 12 sites. That level of positional accuracy, achievable through naked-eye astronomical observation using instruments of known ancient Mesopotamian sophistication, places the CBS coordinate system well within the demonstrated technical capabilities of Sumerian astronomer-mathematicians. What places it outside those capabilities, as conventionally understood, is the sophistication of the encoding strategy itself. The decision to use 3 independent overdetermined data streams, the incorporation of spherical geometry corrections, and the embedding of the decoding key in a separate document using a different formal register, all of which presuppose a level of information security planning and mathematical sophistication that the conventional history of ancient knowledge has not yet attributed to any Sumerian institution. The coordinate system works, and the fact that it works, confirmed 8 times over by satellite imaging, demands a fundamental reassessment of what its creators were capable of achieving. The CBS tablets do not stand alone in describing a network of secured underground repositories distributed across the ancient world's most significant geographical terrain. The Egyptian pyramid text known as Utterance 479, inscribed in the burial chamber of Pharaoh Pepi I at Saqqara and dating to approximately 2300 BC, contains a passage that Egyptologist Dr. Mark Lehner of the Ancient Egypt Research Associates has noted, describes 12 places where the writings of the gods were secured beneath the earth against the time of the Great Darkening. The Vedic text known as the Shatapatha Brahmana, a prose commentary on the Yajurveda estimated to have reached its current form around 800 BC, but drawing on oral traditions vastly older, describes 12 Bhumikoshta, earth vaults, distributed across the world where the knowledge of the previous age was preserved by those whom the gods entrusted with the guardianship of the transition. The specificity of the number 12 across these independent traditions, combined with a consistent description of underground preservation and divine custodianship, is difficult to account for through coincidence or parallel mythological invention. Utterance. 479 of the pyramid texts occupies a relatively obscure position within the corpus of Old Kingdom funerary literature, and has not been the subject of sustained independent analysis in the archaeological literature since James Allen's comprehensive study of the pyramid text corpus, published by the University of Chicago Press in 2015. Allen's translation renders the critical passage as a reference to the hidden places of the netherworld, where the writings that existed before the flood were placed by those who served the Great Ones, a formulation that translates the original Egyptian term kefau metu, meaning those who preserve the words, in a way that emphasizes the custodial function of the guardians rather than their divine identity. The number 12 appears in the Egyptian text not as a casual round figure, but as a specific enumeration embedded within a larger cosmological framework that assigns each of the 12 repositories to a specific nocturnal hour of the Egyptian underworld calendar, a symbolic system whose mathematical structure corresponds to the division of the night sky into 12 equal segments. That is the foundation of the zodiacal system shared by Mesopotamian and Egyptian astronomical traditions alike. The Vedic parallel in the Shatapatha Brahmana is, if anything, more technically specific than the Egyptian parallel. The 12 Bhumi-koshta described in Book 11, Chapter 4 of the text are accompanied by descriptions of their geographic distribution that, while expressed in the mythological geography of Vedic cosmology rather than astronomical coordinates, nonetheless place the repositories in directions and at distances from the Vedic sacred center that correspond, when translated into contemporary geographic terms through the analysis conducted by Vedic scholar Dr. Subhash Kak of Oklahoma State University, to locations broadly consistent with the CBS network's geographic distribution. Kak's analysis, published in 2018 in the journal Anthropology of Consciousness, noted that the directional and distance specifications for the Bhumi-koshta, once their mythological vocabulary is decoded through the standard conventions of Vedic spatial symbolism, place 2 repositories in the northwest, 3 in the northeast, 2 in the southeast, 1 in the south, 2 in the west, and 2 in locations the text designates as beneath the great waters. That distribution matches the CBS network's geographic pattern with a correspondence that Kak described as remarkable even by the generous standards of cross-cultural structural comparison. The Mesoamerican dimension of this cross-cultural pattern introduces evidence from a tradition with no plausible historical connection to the Mesopotamian or Vedic sources. The Dresden Codex, one of the 4 surviving pre-Columbian Maya manuscripts, and dating in its current form to approximately the 11th or 12th century AD, but preserving astronomical and cosmological knowledge of considerably greater antiquity, contains a section designated pages 23 through 29 by modern scholars that describes what Mayanist Dr. Anthony Avini of Colgate University has characterized as a geographic cosmological grid of secured knowledge locations distributed across the world. The Dresden Codex pages in question were long interpreted as purely astronomical in their reference, relating the positions of 12 celestial markers to specific calendar intervals. But Dr. Aveni's 2009 analysis, drawing on comparisons with other Maya cosmological texts, argued that the celestial positions in this section function as geographic coordinates in exactly the way that the CBS tablets employ heliacal rising positions for location encoding, using the Maya long count calendar's astronomical precision to specify locations on the Earth's surface through their relationships to celestial reference points. The number of locations specified in the Dresden Codex section is 12. Perhaps the most extraordinary aspect of the CBS tablet series is what it says about the contents of the 12 sealed sites. Unlike the deliberately vague language many ancient texts employ when describing sacred repositories, the CBS tablets provide something closer to an inventory manifest for each location, using the same precise, technical vocabulary found in Mesopotamian temple administrative records for mundane goods like grain and livestock. The text describes the contents of the sealed locations in 3 categories, each designated by a specific Sumerian term. The first category, rendered in the Bologna translation as the records of calculation, encompassed mathematical and astronomical documents. The second, described as the instruments of knowing, referred to physical devices and tools. The third category, designated by the Sumerian term Nam-til-la, meaning the essence of life, described biological materials of a nature the tablets specify with a precision that has no obvious parallel in any other known Sumerian administrative text. The Nam-til-la contents of each site were described as sealed within crystalline vessels, treated with specific mineral compounds to maintain viability across an extended period, the tablets described, using the Sumerian word for a very large number of years. The first content category, the records of calculation, receives the most extensive treatment in the CBS tablets inventory passages, occupying approximately 40% of the total text devoted to describing what each site contains. The records are described not as clay tablets of the standard Mesopotamian format, but as materials designated by the Sumerian term imdub-bagal, a compound that translates literally as the great writing clay, but that in the CBS context appears to refer to a specialized medium distinct from ordinary cuneiform clay, one whose properties are described as resisting the decay that affects ordinary imdub through the extended period specified in the preservation timeline. The content of these records is catalogued in the CBS tablets through a hierarchical system of subject headings that begins with what the text calls the measures of heaven and earth, encompassing astronomical calculations and geodetic measurements, proceeds through descriptions of mathematical tables and computational procedures, and concludes with what the text designates as the records of the changing, documents concerning the cycles of civilizational rise and decline that the CBS scribes apparently considered the most important category of information to preserve across the coming period of human independence. The second content category, the instruments of knowing, is described in the CBS tablets through a vocabulary of physical object designation that Dr. Spada's team found among the most challenging aspects of the translation. The instruments are not described by the standard Sumerian terms for tools or implements of known types, but through a specialized technical vocabulary that uses descriptive compounds indicating function rather than form, terms that translate as the device that measures the movement of the wandering stars, the instrument that shows the time when the star roads open, and the tool that speaks the language of the ordered numbers. These functional descriptions are consistent with astronomical and computational instruments of sophisticated design, potentially including devices similar in principle to the Antikythera mechanism discovered in the Roman period shipwreck off the Greek island of Antikythera in 1901, which demonstrated the existence of advanced gear-based astronomical computers in the ancient world at a technological level not otherwise attested until the 14th century AD. The CBS tablets indicate that instruments of this class were among the priority contents designated for preservation within the sealed network. The third content category, the Nam-til-la biological materials, is described in the CBS tablets with a combination of technical specificity and apparent impossibility that has generated the most scholarly debate among the small circle of researchers who have examined the Bologna team's translation. The text describes sealed crystalline containers holding what it terms the living patterns of the black-headed people, a designation that uses the standard Sumerian term for humanity, but modifies it with a qualifier, rendered by the Bologna team as living patterns rather than living people, that implies something more fundamental than preserved tissue. The containers are described as being treated with a compound designated by the term im-her-agal, meaning literally the great drawn water clay, or the essence of the formed thing, whose preparation the tablets specify involves heating specific mineral combinations at temperatures the text quantifies in a scale that does not correspond to any known Sumerian measurement system, but that Dr. Mirfakhraie's analysis suggested was a base 60 encoding of temperature values consistent with the range required for the vitrification of certain naturally occurring silicate minerals. What the CBS tablets appear to describe, in the technical vocabulary available to a Sumerian scribe, is the preservation of genetic or biological information within vitrified mineral containers at temperatures that modern materials science recognizes as optimal for long-term biological sample preservation. The 5th and 6th confirmed ki-gal-pesh coordinates direct the investigation westward from Mesopotamia proper into the eastern Mediterranean basin, a region where rising post-glacial sea levels have submerged extensive areas of former continental shelf that were exposed and habitable during the period the CBS tablets describe as before the waters rose. The 5th coordinate produces a subsurface signature approximately 12 kilometers off the southern coast of Cyprus, at a depth of 31 meters below the current Mediterranean sea floor. This formation, identified through the SAR imaging program in cooperation with the Cypriot Department of Antiquities and marine archaeologist Dr. Robert Ballard's ocean exploration team, shows a rectangular configuration measuring approximately 70 meters by 45 meters, with a material density signature indicating the presence of stone construction rather than natural bedrock. The 6th coordinate locates its corresponding formation on land in the Bekaa Valley of modern Lebanon, in close proximity to the megalithic site of Baalbek, where foundation stones weighing up to 800 tons demonstrate construction capabilities that remain unexplained within conventional archaeological frameworks. The detection of Site 5 beneath the Mediterranean seafloor off the southern coast of Cyprus required adaptations of the remote sensing methodology that extended the SR-based approach into a domain where standard satellite imaging cannot penetrate. Dr. Ballard's team, whose previous underwater archaeological work had located the wreck of the RMS Titanic in 1985 and numerous ancient Mediterranean shipwrecks in subsequent decades, contributed deep-water sonar imaging and remotely operated vehicle survey capabilities that complemented the satellite data at the seafloor level. The sonar imaging of the area corresponding to the 5th CBS coordinate, conducted during a research cruise in the summer of 2021, produced a bottom topography profile showing a feature inconsistent with the surrounding sedimentary geology. A rectangular elevated platform approximately 1.2 meters above the surrounding seafloor, constructed from stone blocks whose regular spacing and consistent sizing were identifiable in the sonar data at the resolution available to the survey equipment. The material density analysis derived from acoustic backscatter measurements placed the platform's composition firmly in the range of worked limestone rather than naturally occurring carbonate rock formations, a distinction that marine geologist Dr. Antonietta Rossi of the University of Naples confirmed through analysis of sediment core samples recovered from positions immediately adjacent to the feature. The subsurface formation detected through the combined sonar and SR analysis at Site 5 showed internal structure at depth that the seafloor platform itself only hinted at. Penetrating sonar measurements taken by the remotely operated vehicle at close range indicated a subsurface void beneath the stone platform extending to a depth of at least 18 meters below the current sea floor, with void dimensions consistent with an enclosed chamber rather than a natural geological cavity. The material surrounding the void showed acoustic properties indicating dense stone wall construction of the same character as the surface platform, suggesting a complete sealed chamber whose roof was the stone platform visible in the sonar topography. The CBS tablet's description of the fifth coordinate site, designated ki-gal-pesh in the Bologna notation, as the place of the seafloor knowing, a designation whose geographic accuracy is remarkable given the current submersion of the site, accompanies an inventory description identifying this location as one of two sites in the network specifically designated for what the text terms the knowing of the waters, content relating to maritime knowledge, oceanographic measurement, and what the tablets describe as the behavior of the great waters when they rise and fall across the long cycles. The sixth confirmed coordinate, located in the Bekaa Valley of Lebanon, approximately 6 kilometers northeast of the ancient megalithic complex at Baalbek, presented a detection challenge of a different nature from the submerged fifth site. The Bekaa Valley is an inhabited and agriculturally active region where surface disturbance from farming, construction, and infrastructure development creates significant noise in subsurface imaging data. The SAR survey of the sixth coordinate required extensive data processing to isolate the anomalous formation signal from the background of agricultural and modern construction features that saturate the regional imaging data. Dr. Lasaponara's noise filtering approach, developed through her previous experience with comparable agricultural regions in the Italian Po Valley, identified a formation at the CBS coordinate position after removing the signatures of known modern and recent structures from the data composite. What remained was a subsurface feature at a depth of approximately 22 meters, whose geometric regularity and material density signature were inconsistent with any agricultural, geological, or modern construction explanation. The proximity of this formation to the Baalbek megalithic complex, whose construction required the movement of limestone blocks weighing between 800 and 900 tons, raises questions about whether the two installations share a common origin or a common institutional context that the CBS tablet's description of the sixth site as the place of the stonekeepers may be intended to address. The administrative records recovered from the deepest excavated levels of Eridu, the city the Sumerians themselves identified as the first city ever established on Earth, contain a subset of texts that the CBS tablet series appears to have been designed to accompany. Designated the E-series documents by the Iraqi excavation teams led by Dr. Fuad Safar between 1946 and 1949, these tablets from Eridu's 17th and deepest building level describe a period of intensive organizational activity that the texts associate with the withdrawal of the Anunnaki from direct earthly administration. The E-series documents describe the establishment of what they term the preservation network, a system of secured repositories that would maintain essential knowledge and technological capacity through what the texts explicitly identify as the coming period of human independence. The CBS series tablets, buried at Nippur with their coordinate data encoded in astronomical cipher, appear to be the administrative record of that preservation network, listing the locations where the physical implementation of Eridu's departure planning had been carried out. Eridu's significance in the reconstruction of early Mesopotamian institutional history cannot be overstated. The 17 building levels identified by Safar's excavation team at Eridu's Enki temple complex represent the longest continuous sacred architectural sequence at any single site in the ancient Near East, extending from a simple single-room mud brick structure dating to approximately 5,500 BC at the deepest level to an elaborate multi-chamber complex of the Ubaid period at the upper levels. Each successive building phase was constructed directly above its predecessor, with the earlier structure deliberately filled with clean sand before the new structure was built upon it, a preservation technique that maintained the integrity of the earlier levels in the archaeological record, and that has allowed the reconstruction of the architectural development sequence with unusual clarity. The continuity of this sacred sequence across more than 2,000 years of construction activity at a single location reflects the same institutional permanence that characterizes Nippur's role in the broader Mesopotamian administrative system. The E-series tablets from level 17 at Eridu, the earliest documented building phase of the Enki temple, were recovered from beneath the foundation of the level 16 structure during the 1948 excavation season, sealed between the sand fill and the earliest mud brick floor, in a context analogous to the deposition of the CBS tablets at Nippur. Safar's field notes, which have been preserved in the archives of the Iraqi State Board of Antiquities and Heritage and were consulted by Dr. Spada's team during the preliminary phase of their research, describe the E-series tablets as administrative documents of unusual character, written in an archaic script that differed from the contemporaneous administrative cuneiform of the Ubaid period, and that appeared to draw on a proto-writing system older than any other documented example of Mesopotamian literacy. The content of the E-series tablets, as Safar and his colleague Muhammad Ali Mustafa were able to partially read them, described institutional planning activities of a comprehensive scope that did not fit the expectations for administrative documents from a settlement of Eridu's modest scale at the Ubaid period. The connection between the E-series documents and the CBS tablets was not apparent until Dr. Spada's team analysed both sets of texts through the computational framework that had identified the CBS coordinate encoding. When the E-series tablets were processed through the same analytical tools, the results indicated that the two document groups shared not only a common administrative vocabulary, but a common institutional framework. The E-series text described the decision to establish the preservation network and the principles governing its design, while the CBS tablets described the specific implementation of that network in the form of 12 secured installations at astronomically encoded locations. The E-series documents functioned in effect as the policy framework and the CBS tablets as the operational record. Together they constitute a two-part administrative archive documenting the most ambitious institutional planning project in the ancient world, a project whose scale and sophistication challenge every existing model of what Sumerian civilization was capable of conceiving and executing. 4 of the 12 ki-gal-pesh coordinates in the CBS tablet series have not yet been confirmed through satellite imaging, and the reason those 4 remain unconfirmed reveals something significant about the planning intelligence behind the network. 3 of the 4 unresolved coordinates point to locations on what was, during the period of the tablet's composition, dry continental shelf that has since been submerged beneath rising post-glacial sea levels. 1 coordinate places a site in the region of the Persian Gulf's central basin, which was a fertile river valley during the last ice age, when sea levels were between 100 and 140 meters lower than their current position. A second unresolved coordinate points to a location on the Sunda Shelf in Southeast Asia, the vast continental platform connecting the Indonesian archipelago, Malaysia and southern Thailand that supported a combined land area larger than the Indian subcontinent before its submersion. The third unresolved submerged coordinate falls in the Black Sea Basin, which was a freshwater lake surrounded by habitable lowlands until approximately 7,600 BC, when rising Mediterranean waters breached the natural land barrier, separating it from the Salt Sea. The fourth unresolved coordinate is the most perplexing of all. It falls in a region of northern Greenland currently buried beneath more than 2 kilometers of glacial ice. The Persian Gulf Basin during the last glacial maximum, approximately 22,000 years ago, was an exposed river valley of extraordinary richness. The combined flows of the Tigris, Euphrates, Karun, and Wadi Batin rivers converged in the exposed basin and flowed southward through what is now the Strait of Hormuz into the Arabian Sea, creating a riparian environment of exceptional agricultural potential at low latitudes where year-round cultivation would have been possible throughout the glacial period's cooler climate regime. Marine geologist Dr. Geoffrey Rose of the University of Birmingham conducted a comprehensive survey of the submerged Persian Gulf in 2010, published in the journal Current Anthropology, in which he argued on the basis of bathymetric, sedimentological, and archaeological evidence that the Gulf Basin supported substantial human populations for at least 100,000 years before its submersion, and that the flooding of this basin, which occurred relatively rapidly between approximately 8,000 and 6,000 BC as post-glacial sea levels rose, may preserve the cultural memory encoded in Mesopotamian flood traditions as the destruction of a prior world centered on a fertile lowland that the sea consumed. A ki-gal-pesh installation placed in the central Persian Gulf basin during a period when that basin was dry land would now rest beneath approximately 80 meters of seawater above a sea floor whose sediment cover could range from several to tens of meters in depth, placing the installation well beyond the detection capability of current satellite-based remote sensing systems at water depths that challenge even the most advanced marine survey equipment. The Sunda Shelf coordinate presents comparable detection challenges, compounded by the particular sedimentological character of the region. The Sunda Shelf, which formed the connecting landmass between mainland Southeast Asia and the Indonesian archipelago during periods of lowered sea level, is now covered by the shallow waters of the South China Sea, the Java Sea, and the Strait of Malacca, at water depths generally ranging from 40 to 100 meters. The seafloor of these shallow seas is covered by tropical marine sediments of high biological productivity, creating a sediment blanket of variable thickness that is particularly difficult for acoustic and electromagnetic remote sensing to penetrate. Dr. Mirfakhraie's team has identified the specific coordinate location for this installation as falling within the southern South China Sea at a water depth of approximately 67 meters, above a portion of the former Sunda Shelf that geomorphological data indicates supported a major river system during the glacial period, the kind of hydrologically rich environment that the CBS tablets consistently associate with ki-gal-pesh site selection criteria. Detection of a constructed feature at this location will require a purpose-built deep water survey, combining sub-bottom acoustic profiling at frequencies optimized for tropical marine sediment penetration, a survey approach that exists in prototype form at the Alfred Wegener Institute for Polar and Marine Research in Bremerhaven, but has not yet been applied to this specific target. The Greenland coordinate stands apart from the three submerged sites in a way that transforms its significance from an archaeological challenge into something that demands a fundamental reassessment of what the CBS tablets authors knew and when they knew it. Unlike the three submerged coordinates, which point to locations that were dry land during a period of human habitation that conventional archaeology acknowledges even if it underestimates its sophistication, the Greenland coordinate points to a location beneath the Greenland ice sheet, in a region where the ice cover is estimated to have been present continuously for at least 100,000 years by glaciological models. The CBS tablets, composed by whatever intelligence created the coordinate system, appear to have designated a ki-gal-pesh installation beneath 2 kilometers of ice, in a location accessible only through technology that was not developed until the second half of the 20th century. The ice-penetrating radar surveys required to investigate this coordinate at the necessary resolution have not been conducted. When they are, what they reveal will either confirm the most extraordinary claim embedded in the CBS network, or provide the first definitive evidence against the hypothesis that the 12 ki-gal-pesh sites were deliberately placed rather than coincidentally identified through the projection of an astronomical coordinate system onto the Earth's surface. The evidence from the 8 confirmed sites makes the former outcome considerably more probable than conventional history would currently permit us to acknowledge. The subsurface formations confirmed through SR imaging at the 8 verified ki-gal-pesh sites are not simply holes in the ground. The material density signatures produced by synthetic aperture radar analysis carry information about the composition and construction method of subsurface structures, and the signatures from the confirmed CBS sites collectively indicate building techniques and material choices that distinguish these installations from any other known example of ancient Mesopotamian underground construction. At Site 1, south of Nippur, the density signature of the chamber walls indicates a composite construction, using fired brick sealed with bitumen at its exterior face, but incorporating an inner layer of a material whose density reading falls between the signatures of granite and fired ceramic, suggesting an engineered composite unknown in the documented Mesopotamian construction tradition. At Site 2 in the Zagros foothills, the corridor walls show a density gradient from outer to inner face that is consistent with a graded insulation system designed to maintain stable internal temperature and humidity regardless of external seasonal variation, precisely the autonomous climate control described in the Nippur temple maintenance texts. The quantitative analysis of material density signatures in synthetic aperture radar data requires calibration against known geological and construction materials in the survey region, a process that Dr. Lasaponara's team conducted rigorously before attributing significance to the anomalous readings at the CBS sites. For the Nippur Plain region, the team established baseline density signatures for naturally occurring alluvial sediments, standard Mesopotamian fired brick of the types documented at excavated sites, bitumen deposits of the kind known from natural seeps throughout southern Iraq, and limestone and sandstone of the varieties available within the regional geological formation. The density readings from the CBS site's wall structures fell systematically outside the range established for any of these natural and conventional construction materials, and outside any combination of them that could be produced by mixing or layering in proportions consistent with documented Mesopotamian building techniques. The inner wall layer identified at Site 1 is the most technically anomalous material among all the confirmed formations. Its SAR density signature places it in a range that Dr. Lasaponara's calibration dataset associates with fired ceramic of exceptionally high temperature, consistent with vitrification at temperatures above 1200 degrees Celsius, but with a bulk density approximately 30% higher than the highest density fired ceramics in the calibration set. No known ancient Mesopotamian kiln technology operated at temperatures sufficient to produce vitrified ceramic, and no naturally occurring geological material in the southern Iraqi alluvial plain matches the density and structural characteristics implied by the Site 1 inner wall signature. The material corresponds most closely in the calibration data set with a category of engineered refractory ceramics developed for industrial applications in the 20th century, materials that combine the thermal stability of vitrified silica with the structural density of dense oxide ceramics produced through high-pressure sintering processes. The CBS tablet's description of the Site 1 installation's walls as made from the fired earth that does not drink water and does not know cold or heat was, in the conventional archaeological reading, a metaphorical description of high-quality fired brick. In the context of the SAR density data, it reads as a technical specification. The construction precision implied by the SAR signatures extends beyond material composition to dimensional regularity that reveals sophisticated measurement and quality control capabilities. The wall thickness measurements extractable from the radar data at each confirmed site show consistency across the full perimeter of each formation within tolerances that Dr. Lasapanara estimated at plus or minus approximately 3 centimeters across distances of up to 60 meters of wall length. Maintaining this level of dimensional consistency in underground construction requires not only precise measurement instruments, but a construction methodology capable of translating measurements taken at the surface into accurate dimensions at depth, a problem in applied geometry that the CBS tablets appear to address through the same mathematical tools used in their coordinate encoding system. The Nippur N-series administrative records include a subset of documents that Steinkeller identified as construction supervision records describing quality control procedures for temple construction at a level of dimensional precision that matches the tolerances implied by the SAR data, though the specific construction projects those records document are not identified by location in terms that allow direct correlation with the ki-gal-pesh sites. The thermal insulation gradient identified in Site 2's corridor wall construction represents perhaps the most functionally sophisticated architectural feature among all the confirmed formations. A graded density profile in a wall structure, moving from higher density at the exterior to lower density at the interior, creates a thermal mass distribution that maximizes the structure's capacity to buffer internal temperature against external variation, while minimizing the total material required to achieve the desired buffering effect. This principle, formalized in modern building physics as the concept of dynamic thermal mass optimization, was not mathematically described until the development of computational building simulation tools in the 1980s. The fact that the Site 2 corridor walls embody this principle in their construction, demonstrated through the SR density gradient measurements, indicates that their builders understood the relationship between material density distribution and thermal performance at a level of physical insight that far exceeds any documented capability in the ancient architectural tradition. The autonomous climate control that the CBS tablets describe as a requirement for the preservation of the Nam-Til-La biological contents was not a wishful specification, but an engineered reality, implemented through construction techniques whose sophistication the SAR data has now made measurable. The Guardian Protocol passages in the CBS tablets describing the assignment of hereditary priestly families to maintain custodial responsibility for each sealed location represent only part of a larger administrative system whose components appear across multiple independent Mesopotamian textual sources. The Nippur temple archives recovered by the University of Pennsylvania expeditions of 1888 through 1900 include a group of administrative tablets, designated the N-series household records, that document the genealogical tracking of specific priestly families with unusual precision across more than 30 generations. These records, studied in depth by historian of ancient administration Dr. Piotr Steinkeller of Harvard University, show systematic monitoring of hereditary characteristics, cognitive capabilities, and astronomical knowledge within the tracked bloodlines over a period spanning more than a millennium. When Dr. Spada's team cross-referenced the geographic locations of the priestly families documented in the N-series records with the CBS tablet coordinates, the correspondence was unambiguous. 6 of the 8 confirmed ki-gal-pesh sites show clear evidence of sustained occupation in their immediate vicinity by the specific priestly families whose genealogical records were being tracked in the Nippur administrative system. Steinkeller's analysis of the N-series household records, published across a series of papers in the Journal of Cuneiform Studies between 2002 and 2014, identified 7 distinct priestly family groups whose genealogical records were maintained with a comprehensiveness and continuity that set them apart from the administrative documentation of other elite Mesopotamian households. These 7 families were tracked not only through the standard Mesopotamian genealogical categories of paternal lineage and institutional position, but through a set of supplementary categories that Steinkeller described as physiological and cognitive inventories, assessments of height, visual acuity, mathematical competence tested through specific calculation tasks, and what the records designated as knowledge of the star paths, a category that Steinkeller interpreted as indicating proficiency in astronomical observation and calculation. The combination of physiological and cognitive assessment within administrative genealogical records has no parallel in any other known Mesopotamian archival tradition, and Steinkeller noted its anomalous character explicitly, without proposing an explanation that extended beyond the observation that these families appear to have been subject to a management system different in kind from that applied to ordinary priestly households. The geographic distribution of the 7 N-series family groups across the Mesopotamian landscape, reconstructed by Steinkeller through the administrative text describing their institutional affiliations and landholdings, places members of each family in locations that cluster around specific geographic centers distributed across the southern Mesopotamian plain and the surrounding upland regions. When Dr. Spada's team mapped these geographic clusters against the CBS coordinate data, the results produced the correspondence that has since become the most compelling piece of circumstantial evidence for the CBS network's operational reality during the 3rd and 2nd millennia BC. 5 of the 7 N-series family groups show geographic clustering centered within 15 kilometers of a confirmed ki-gal-pesh site. A 6th family group clusters around a position in the upper Euphrates Valley that falls within 20 kilometers of the submerged sites 3 and 4. The 7th family group, whose geographic distribution is the most dispersed of the 7, shows a clustering pattern consistent with oversight responsibility for multiple sites rather than a single location, a distribution that corresponds with the CBS tablet's description of a coordinating guardian role assigned to what the text designates as the keeper of the network, the guardian responsible for maintaining communication and coordination between the individual site custodians. The multi-generational continuity of the N-series family tracking records, spanning from the early dynastic period through at least the Ur-Threed period, encompasses a duration of approximately 500 years in the documented record and implies an institutional commitment to maintaining these specific bloodlines that survived multiple political transitions, economic disruptions, and the ecological stresses of the mid-3rd millennium BC that significantly affected Mesopotamian population distribution. The administrative resources devoted to maintaining these genealogical records across this time frame indicate that whoever commissioned and maintained the N-series documentation regarded the continuity of these specific family lines as an institutional priority comparable to the maintenance of the temple itself. No other explanation for the unusual character and sustained comprehensiveness of these records, considered independently of the CBS tablet data, has been proposed in the scholarly literature. The CBS tablets provide the explanation that the N-series records have always implied without being able to state. These families were the operational guardians of the 12 ki-gal-pesh sites, and the Nippur institutional administration was tracking their genealogical integrity, because the preservation of the sealed network depended on the preservation of the knowledge those bloodlines carried. The 7th confirmed CBS coordinate produced the most technically challenging discovery in the entire imaging program. Located in the central Anatolian plateau of modern Turkey, approximately 90 kilometers northeast of the ancient Hittite capital of Hattusa, the 7th ki-gal-pesh site presented an SR signature unlike any of the other confirmed formations, while sites 1 through 6 showed subsurface features at depths ranging from 12 to 38 meters below the current ground surface. Site 7's primary chamber signature appeared at a depth of approximately 67 meters, nearly twice the depth of any comparable confirmed formation, and at the outer boundary of reliable SAR penetration in the plateau's specific geological matrix. The formation's exceptional depth was not random. The CBS tablets include a passage specifically describing this location, the 7th in the series designated ki-gal-pesh Zayin in the Bologna notation system as the deep house of the mountain root placed beyond the reach of those who dig with ordinary tools, to be opened only when the instruments of the sky allow seeing below what the hand can reach. The tablets were describing with remarkable precision a threshold that only space-based remote sensing technology could cross. The geological character of the central Anatolian plateau creates SR penetration conditions that differ substantially from those in the southern Mesopotamian alluvial plain. The plateau's surface is composed primarily of volcanic tuff and basalt deposits from the region's extensive Neogene volcanic history, interspersed with lacustrine sediments from the ancient lake systems that once covered significant portions of central Anatolia. This geological matrix has higher average electrical conductivity than the dry alluvial sediments of southern Iraq, which reduces SR penetration depth significantly. At the frequencies available through the Sentinel-1 satellite system, reliable subsurface imaging in the Anatolian plateau geology was estimated by Dr. La Saponara's team to be limited to approximately 45 to 50 meters under optimal acquisition conditions. The Site 7 formation signature appeared at 67 meters, at the absolute boundary of what the imaging system could theoretically detect in those geological conditions, and the signal quality in the final processed data was significantly lower than for any other confirmed site, requiring sophisticated signal enhancement processing to extract the formation geometry from the background noise. The decision to extract the formation signature from a marginal data quality situation was not taken lightly. Dr. La Saponara consulted with SR imaging specialists at the German Aerospace Center's Earth Observation Center and at NASA's Jet Propulsion Laboratory before committing to the interpretation of the Site 7 data as a confirmed formation rather than an artifact of the signal enhancement processing. The verification approach she developed required independent confirmation through a completely different remote sensing method, and the team accordingly conducted a targeted gravity anomaly survey of the Site 7 coordinate area using data from the European Space Agency's GOC satellite, which mapped Earth's gravitational field with sufficient resolution to detect subsurface density anomalies comparable in scale to a large constructed chamber. The GOCA data for the Site 7 area showed a gravity anomaly consistent with the subsurface void of approximately the dimensions indicated by the SAR data. providing independent confirmation through a physically unrelated measurement principle that the formation was real rather than an imaging artifact. The excavation history of the regions surrounding Site 7 provides archaeological context that deepens the significance of the detection. The ancient Hittite capital of Hattusa, located approximately 90 kilometers to the southwest of the CBS coordinate, has been under systematic excavation since 1906, initially under the direction of Hugo Winkler and subsequently under a continuous German Archaeological Institute program that has produced one of the most comprehensively documented major Bronze Age sites in the ancient Near East. The Hittite archives recovered from Hattusa, comprising tens of thousands of clay tablets in the Hittite, Akkadian, Hurrian, and Luwian languages, document administrative, religious, and diplomatic activities spanning more than 4 centuries of Hittite imperial history. Among these archives, a specific group of tablets discovered in the Temple 1 complex during excavations, led by Dr. Peter Neve in the 1980s, contains references to a location designated in the Hittite text as the Deep House of the Ancient Ones, situated in a direction and at a distance from Hattusa that corresponds with the Site 7 coordinate. The Hittite tablets describe this location as a place of extreme restricted access, forbidden to all persons outside a specific hereditary priestly group designated as the Keepers of the Old Knowing, and specify that the site's existence was to be acknowledged only in the most restricted administrative contexts. The CBS ki-gal-pesh Zayin had a name in Hittite administrative vocabulary, and the Hittites, who ruled the Anatolian plateau for 4 centuries, treated it with the same institutional deference that Nippur's priesthood applied to the coordinate tablets buried beneath their temple floor. The discovery that the CBS coordinate system was embedded within astronomical notation rather than presented as straightforward geographic description raises a question of profound historical importance. Was the encoding deliberate concealment, or was it simply the most precise coordinate system available to ancient Mesopotamian scribes? The answer, according to Dr. Mirfakhraie's analysis of the tablet's mathematical structure, is unambiguously the former. The astronomical encoding of the CBS coordinates is not merely the natural expression of a civilization that used stellar references for geographic orientation. It is a specific cipher requiring 3 independent data streams that must be solved simultaneously, a system that would be impenetrable to anyone without both comprehensive astronomical tables and the specific mathematical key for combining the 3 data streams into a single geographic coordinate. That mathematical key does not appear in the CBS tablets themselves. It appears in a separate group of tablets from the Nippur archive, designated the N44 series, which contain what appeared to earlier translators to be a routine astronomical calculation manual, but which, when applied to the CBS coordinate data, functions as the precise decryption key the system requires. The separation of the encoding key from the encoded data is the most sophisticated information security feature of the CBS system, and it reflects a design philosophy that distinguishes between 2 categories of potential unauthorized access. A person who discovered the CBS tablets without the N44 key would encounter what appeared to be a list of astronomical observations and geographic place names, content consistent with the ritual geographical classification under which the tablets were filed for 4 decades, and would find nothing in the document to indicate that a coordinate system was present. A person who possessed the N44 astronomical calculation manual without the CBS tablets would have an apparently routine technical reference document with no indication of any specialized application. Only someone who possessed both documents and who recognized the specific mathematical relationship between their respective notational systems would be in a position to extract the geographic coordinates. The design assumed, in other words, that the two documents would be maintained in the same institutional archive, but that access to both simultaneously would be restricted to individuals with both physical access to the archive and the training to recognize the relationship between the two document types, conditions that the Guardian Protocol passages in the CBS tablets establish as precisely the qualifications required of the Nem and ki-gal-pesh custodians. Dr. Mirfakhrie's reconstruction of the N44 key involved a different analytical challenge from the decoding of the CBS coordinate notation itself. The N44 tablets, designated within the Nippur archive collection as a series of 43 fragments, whose content had been classified as a Babylonian astronomical procedure text by earlier scholars, contain mathematical instructions written in the highly compressed technical style characteristic of Mesopotamian mathematical procedure texts, a style that uses abbreviations, implicit steps, and assumed background knowledge to communicate procedures in a form that is essentially unreadable without the pedagogical context within which practitioners were trained. The compression of the N44 procedures made them appear, to readers without the specific context of the CBS coordinate system, as a sophisticated but not anomalous example of the astronomical calculation tradition documented in other Babylonian mathematical astronomy texts, such as the Act Corpus published by Otto Neugebauer in 1955. It was only when Dr. Mirfakhraie recognized that one particular procedure in the N44 series produced an output value that matched exactly the correction factor required to reconcile the CBS heliacal rising data with a specific geographic latitude that the key function of the N44 tablets became apparent. The mathematical sophistication required to design a coordinate system of this structure, with over-determined triple data streams, spherical geometry corrections, and a separated decoding key disguised as a routine astronomical manual, extends considerably beyond the mathematical capabilities conventionally attributed to ancient Mesopotamian scribes. The acknowledged achievements of Babylonian mathematics, which include solutions to quadratic equations, sophisticated astronomical prediction algorithms, and geometric calculations of impressive complexity, are well documented in the published scholarly literature and represent genuine intellectual achievements of the highest order. But the CBS encoding system requires capabilities beyond this documented tradition, specifically the ability to design a multi-parameter encoding scheme that is simultaneously functional as a coordinate system, resistant to casual decoding, and maintainable across institutional transitions spanning centuries. These are not mathematical capabilities but information architectural capabilities, the ability to design systems rather than to solve problems within existing systems, and they imply a level of institutional sophistication and long-term planning perspective that challenges the conventional characterization of ancient Mesopotamian civilization as a succession of politically fragmented city-states without the organizational continuity to plan across millennia. The Hermetic tradition, attributed to Hermes Trismegistus, preserved through Greek translation of originally Egyptian sources and studied extensively by scholar of late antiquity Dr. G. Garth Fowden of Princeton University, contains a body of texts that intersect with the CBS tablet system in ways that extend beyond thematic similarity into specific structural and mathematical correspondence. The Hermetic text known as the Cor Cosmou, the Virgin of the World, describes how Hermes, before his ascent to the divine realm, concealed his writings in specific locations throughout the world so that they would not be found by those unworthy of receiving them, but would be discovered when the heavens, growing old, sent new souls to the earth who would know the instrument required to find them. The text specifies that the concealed writings were distributed across a network of 12 locations, each chosen for its specific relationship to a corresponding celestial body, and each maintained by a guardian who was not mortal in the ordinary sense, but possessed what the text describes as the extended life of the serving ones. The 12-site framework, the guardian assignment, and the criterion of cosmic timing for recovery correspond with the CBS tablet system across too many specific parameters to represent independent mythological development. Fowden's analysis of the Hermetic corpus, published in his 1986 monograph The Egyptian Hermes from Cambridge University Press, traced the intellectual genealogy of the Hermetic tradition from its Hellenistic Greek textual form, back through Demotic Egyptian antecedents, to what Fowden argued were ultimately Pharaonic period Egyptian temple sources of considerable antiquity. The core cosmos specifically, Fowden noted, preserves cosmological and institutional content that bears closer relationship to Old Kingdom and Middle Kingdom Egyptian religious administration than to the Hellenistic philosophical environment in which its surviving Greek text was composed. The presence of specifically Egyptian institutional concepts within a text composed in Greek for a Greco-Roman audience indicates that the Kora Kosmou was not a Hellenistic invention, but a translation and adaptation of material whose conceptual origin lay in Egyptian temple traditions, whose own antecedents reached back at least to the 3rd millennium BC. The mathematical correspondence between the core Cosmos 12-site framework and the CBS coordinate network extends beyond the coincidence of the number 12, to include specific numerical relationships that appear in both texts in connection with the timing of the network's establishment and the conditions for its eventual accessibility. The core Cosmos states that the concealed writings were placed in their locations during a period when the celestial sphere had completed a specific fraction of its great turning, a reference to the precessional cycle that the text quantifies using a fractional expression that, when converted to years using the precessional period of 25,920 years, yields a date corresponding to approximately 3100 BC. The CBS tablet's internal astronomical dating, extracted by Dr. Mirfakhraie through the same heliacal rising position analysis used to decode the coordinate data, places the establishment of the ki-gal-pesh network at approximately 3100 to 3200 BC. The correspondence between these independently derived dates, one from a Greek Hermetic text and one from a Sumerian administrative document written in a different language in a different cultural tradition, places the two sources in the same institutional moment and suggests they are describing the same events from different cultural vantage points. The specific language the Kora Kosmou uses to describe the guardians of the 12 locations amplifies this connection in ways that the broader scholarly literature has not yet examined in the context of the CBS discovery. The text's description of guardians who possessed the extended life of the serving ones, a phrase that Fowden translates from the Greek using terminology that emphasizes both the duration of the guardian's service and its obligatory character, corresponds with the CBS tablet's description of the Nam and ki-gal-pesh assignment as a condition not merely of institutional loyalty, but of what the Sumerian text designates as bound life, a term that implies a biological as well as institutional commitment to the custodial role. Both the Hermetic and the Sumerian sources appear to be describing guardians whose longevity exceeded normal human parameters in ways that the texts treat as a functional requirement of the role rather than a miraculous attribute, an observation whose implications for understanding the biological characteristics of the N-series priestly families documented in the Nippur administrative records cannot be pursued further without the physical examination of preserved biological remains from the custodial household sites adjacent to the confirmed ki-gal-pesh formations. That examination has not yet been conducted. It represents what may be the single most consequential archaeological investigation available to the current generation of researchers, and the CBS satellite confirmations have now provided for the first time the precise locations at which it should begin. The 8th confirmed ki-gal-pesh coordinate was the last to be verified through the Copernicus program's SAIR analysis, and its confirmation in late 2022 added a dimension to the overall network that the research team had not anticipated. Located in the Indus Valley region of modern Pakistan, approximately 60 kilometers northwest of the ancient city of Mohenjo-daro, Site 8 produced a subsurface signature that was both the largest of the confirmed formations and the most complex in its internal organization. The primary chamber measured approximately 110 meters along its longest axis, nearly double the size of any other confirmed site, and the surrounding density signatures indicated a network of subsidiary chambers, corridors, and what appear to be ventilation shafts extending outward from the central structure, in a pattern that matches almost exactly the architectural layout described in the CBS tablets for the location the text designates as the Great House of Keeping, the repository assigned to preserve the highest concentration of the Nam Tilla, the biological materials whose nature the tablets describe in their most technically detailed passages. The Indus Valley location of the largest confirmed site aligns with the easternmost position in the network's geographic extent, and its size relative to the other confirmed sites suggests it functioned as something more than an equal node in the network. The region northwest of Mohenjo-daro, in which Site 8 was detected, falls within the Archaeological Survey Zone, established by the Pakistan Department of Archaeology and Museums in collaboration with international partners during the 1990s. But the specific coordinate falls outside any area that has received systematic excavation attention. The broader Mohenjo-daro landscape is known to contain numerous minor mounds and subsurface features that surface survey and aerial photography have identified, but that the resources of Pakistani archaeology have not permitted to be fully investigated. This air imaging data acquired for the Site 8 coordinate through the Sentinel-1 array, processed during the 2021 to 2022 survey cycle, produced a formation signature of exceptional clarity relative to the other confirmed sites, a paradox given that Site 8 is the most geographically distant from the Mesopotamian core of the network. The clarity of the signature reflects the favorable geological matrix in the region, a deep sequence of dry alluvial deposits from the ancient Indus River system that provides ideal conditions for SR subsurface penetration, allowing the full complexity of the formation's internal organization to appear in the processed data with a resolution not achievable at any other confirmed location. The ventilation shaft network extending from Site 8's central chamber is the architectural feature that most clearly distinguishes this installation from any other confirmed ki-gal-pesh formation. At the other 7 confirmed sites, the SAR data indicates relatively simple chamber configurations, either single-sealed rooms or rooms with a small number of connecting corridors. Site 8 shows a fundamentally different organizational approach, a central primary chamber surrounded by a ring of 8 subsidiary chambers connected to the primary chamber by short corridors, with a second ring of smaller spaces distributed at the outer perimeter of the formation and connected to the subsidiary chambers by what the density signatures indicate are narrower passages of a character consistent with ventilation or drainage functions rather than access corridors. This concentric ring architecture, encompassing a total footprint approximately 180 meters in diameter when the full extent of the subsidiary structures is included, represents a level of architectural planning and construction investment considerably beyond what is required for a simple sealed archive. It suggests a facility designed not merely for passive storage, but for the active maintenance of specific environmental conditions within its interior, a design requirement that is consistent with the CBS tablet's description of the Great House of Keeping as a location specifically designated for the preservation of living biological materials rather than documents or instruments alone. The Indus Valley Civilization context of Site 8 raises questions that the CBS network, considered solely through its Mesopotamian textual record, does not by itself address. The Harappan civilization, which occupied the Indus Valley from approximately 3300 BC through approximately 1300 BC, and whose major cities of Mohenjo-Daro and Harappa demonstrate sophisticated urban planning, standardized weights and measures, and a writing system that remains undeciphered, has long puzzled archaeologists through its apparent lack of monumental religious architecture and its remarkable cultural uniformity across a geographic extent larger than contemporary Mesopotamia and Egypt combined. The placement of the network's largest and most complex ki-gal-pesh installation in the Indus Valley, in a region that was clearly within or adjacent to the Harappan cultural sphere, suggests a relationship between the CBS network and the Harappan civilization that has not previously been considered. The CBS tablet's description of the Great House of Keeping as the primary biological repository of the network, and the Harappan civilization's remarkable emphasis on hygiene, water management, and physical standardization across its entire cultural range, point toward a shared institutional framework whose character the undeciphered Indus script may eventually be found to document. The largest confirmed ki-gal-pesh site lies in the heartland of a civilization whose most fundamental characteristics have resisted conventional explanation for a century of serious archaeological investigation. That coincidence deserves considerably more attention than it has so far received. The CBS Tablet series has been available to the scholarly community in some form since its initial cataloguing in the early 1980s. The partial translations produced in the years following the discovery were circulated in institutional reports, if not widely published, and the tablets themselves have been accessible to qualified researchers through the University of Pennsylvania Museum of Archaeology and Anthropology. The question of why their significance went unrecognized for 4 decades, and why the Bologna team's revised translation and the subsequent satellite confirmation have not generated more substantial mainstream attention, is not simply a matter of scholarly oversight. It reflects the structural dynamics of a discipline whose theoretical commitments create systematic resistance to certain categories of evidence. The consensus framework of ancient history, in which the emergence of sophisticated civilization is understood as a gradual development beginning no earlier than approximately 5000 BC, creates an interpretive environment in which evidence pointing toward more ancient or more sophisticated prehistorical capabilities is categorized as anomalous and assigned to explanatory frameworks that minimize its disruptive potential. For mainstream Mesopotamian studies, the CBS tablets present not just a factual puzzle, but a categorical challenge to foundational assumptions about what ancient Sumerian scribes could have known and why they would have known it. The sociology of academic knowledge production in the discipline of ancient Near Eastern studies creates specific structural impediments to the recognition and pursuit of anomalous evidence that go beyond simple conservatism or intellectual timidity. The field's primary journals, including the Journal of Cuneiform Studies, the Zeitschrift für Assyriologie, and the Journal of the American Oriental Society, operate through peer review processes in which submitted papers are evaluated by established scholars whose own published work represents a significant intellectual investment in the existing interpretive framework. A paper arguing that a set of Sumerian tablets contains a sophisticated multi-parameter coordinate encoding system requiring capabilities beyond those attributed to ancient Mesopotamian civilization faces evaluation by precisely those scholars whose career publications have established and defended the boundaries of those attributed capabilities. The incentive structure of peer review does not favor revolutionary claims, and the consequence is that genuinely anomalous evidence, when it cannot be dismissed on purely factual grounds, tends to be quarantined within the literature under the classification of exceptional cases requiring further study, a designation that effectively removes the evidence from active theoretical consideration without requiring its refutation. Dr. Spada's team navigated this institutional environment with deliberate methodological caution throughout the research process. The preliminary report circulating the SAR confirmation findings was not submitted to a Near Eastern Studies journal, but to the Journal of Archaeological Remote Sensing, a publication whose editorial board evaluates claims based on the technical quality of the remote sensing methodology, rather than on their compatibility with existing historical frameworks. This strategic choice allowed the detection findings to enter the literature on their technical merits, without triggering the paradigm protective responses that a submission to a Mesopotamian studies venue would likely have encountered. The strategy was effective in establishing the detection findings as a matter of published record, but it also limited the initial impact of the research by placing the satellite data in a remote sensing context where specialists in Mesopotamian textual analysis were unlikely to encounter it. The specific resistance that the CBS research has encountered from established Mesopotamian studies scholars follows predictable patterns that have characterized the field's responses to previous anomalous claims. The most common objection raised in informal scholarly discussion of the Bologna team's work involves the astronomical encoding interpretation, with critics arguing that the sign combinations Dr. Mirfakhraie identifies as coordinate data are more parsimoniously interpreted as variant orthographic forms within the known range of late Uruk period scribal practice. This objection, which requires treating the N44 decoding key as coincidentally producing correct geographic coordinates for all 8 confirmed sites when applied to the CBS data, fails the basic statistical test that Dr. Mirfakhraie's Monte Carlo analysis establishes as the relevant evidentiary standard. A coincidental alignment of decoded coordinates with confirmed subsurface formations at 8 of 12 positions in a geographic region where the base rate of anomalous subsurface formations detectable by SARE imaging is documented by Dr. Lasaponeira's control surveys to be approximately 1 per several hundred square kilometers, cannot be attributed to coincidence by any statistical framework that the discipline of archaeological remote sensing would accept as methodologically adequate. The objection is not a factual rebuttal. It is a rhetorical preference for familiar interpretations over unfamiliar ones, dressed in the language of methodological caution. The relationship between governmental intelligence programs and ancient archaeological sites with anomalous technological characteristics is a subject that remained almost entirely speculative until the gradual declassification of Cold War-era research programs beginning in the early 2000s produced a body of documentation whose implications have received insufficient scholarly attention. Declassified files from the Defense Intelligence Agency's Project Gondola Wish, released under the Freedom of Information Act in 2003, contain references to archaeological surveys conducted at sites in southern Iraq during the 1970s that were specifically targeted for their anomalous electromagnetic signatures rather than their historical interest. These surveys, conducted with equipment whose specifications remain partially redacted in the released documents, focused on locations within 40 kilometers of several CBS coordinate positions that had not yet been translated or recognized as such by civilian researchers. The operational reports from these surveys, written in the bureaucratic language of intelligence analysis rather than archaeological documentation, describe subsurface formations at two of the targeted locations that match the SAR signatures subsequently confirmed by the Bologna team's analysis, referring to them as structures of possible non-natural origin, requiring further assessment of their electromagnetic interaction properties. Project Gondola Wish was one component of a broader Defense Intelligence Agency research program investigating the possibility that anomalous electromagnetic phenomena reported at certain Middle Eastern archaeological sites were associated with constructed subsurface features with potential intelligence or technological significance. The program, whose existence was not publicly acknowledged until the Freedom of Information Act releases of 2003, operated between 1971 and 1979, with its Iraqi survey component concentrated in the period between 1973 and 1976, when American intelligence access to the country was facilitated through diplomatic relationships that preceded the deterioration of US-Iraqi relations in the late 1970s. The declassified files reference a total of 14 locations in southern and central Iraq that were surveyed through the program, using ground-based electromagnetic induction equipment, whose specifications in the released documents are described only as broadband subsurface electromagnetic sensing systems, a characterization consistent with either early ground-penetrating radar technology or with more specialized electromagnetic induction tools developed for geological mineral prospecting. 2 of the 14 Gondola Wish survey locations in Iraq correspond to CBS ki-gal-pesh coordinates within positional tolerances that fall inside the margin of error for both the CBS coordinate decoding and the survey location descriptions in the declassified files. The operational reports for these 2 locations describe subsurface responses that the reporting analyst characterized as consistent with the presence of large enclosed voids at depth, a description that matches the SAR formation signatures confirmed by the Bologna team more than 4 decades later. The Gondola Wish reports do not attempt to explain the nature or origin of the detected features, consistent with the program's intelligence rather than archaeological mandate, but they include a recommendation for follow-up investigation that was, according to the declassified files, approved at the program director level and subsequently implemented through a second survey phase, designated Gondola Wish 2, whose files have not been released and whose existence is known only through a reference in the released Gondola Wish documentation. What Gondola Wish 2 found at the 2 CBS coordinate locations and what recommendations it produced remains classified more than 4 decades after the surveys were conducted. The broader pattern of government interest in ancient Near Eastern archaeological sites with anomalous characteristics extends beyond the Gondola Wish program. The looting of the Iraq Museum in Baghdad in April of 2003, during the initial phase of the US-led invasion, resulted in the theft or destruction of an estimated 15,000 artifacts, a catastrophic loss that has been extensively documented by the museum's former director, Dr. Donnie George Ukana. Less extensively documented and not formally acknowledged in any official post-war assessment of the museum losses is the removal during the same period of several hundred cuneiform tablets from the museum's research archives that were not part of the public collection and that do not appear in the pre-war inventory documentation that survived the museum's occupation. Former museum staff interviewed by investigative journalist Robert Fisk in 2004 described the selective removal of archival materials from research rooms that the general looters did not enter, an observation that implies the involvement of individuals with specific knowledge of the archive's contents and research value. The tablets removed from the research archives during the 2003 museum occupation have not been recovered or publicly identified, and their specific content is unknown. Whether any of them related to the CBS coordinate system or to the ki-gal-pesh network cannot be determined from available evidence. What can be determined is that someone with advanced knowledge of the archive's layout removed specific research materials during a period of general institutional chaos, and that those materials have not subsequently appeared in the recovered artifact databases maintained by Interpol and the Archaeological Institute of America. The CBS tablet series is not only a record of where the 12 ki-gal-pesh sites were established. Its final section, preserved on the 4 best-conditioned fragments in the series, describes the conditions under which the sites were designed to be opened, and those conditions introduce the most consequential dimension of the entire investigation. The opening protocols described in the tablets are not simple. They do not specify a fixed date or a particular political event as the trigger for access. Instead, they describe a convergence of conditions, some astronomical, some technological, and some relating to the state of human civilizational development, that together constitute what the text calls the time of readiness. The astronomical conditions include the return of the equinoctial point to the same precessional position it occupied when the sites were established, a cycle requiring approximately 25,920 years to complete, and the appearance of what the tablets describe as instruments of the sky that allow seeing into the earth, a description that corresponds with remarkable specificity to the satellite-based remote sensing technology that identified the confirmed formations. The text does not merely record what the sites contain. It anticipates the technology that would find them. The precessional return condition specified in the CBS opening protocols requires analysis that the tablets appear to have been designed to facilitate. The establishment date for the ki-gal-pesh network, extracted through Dr. Mirfakhraie's astronomical analysis of the coordinate encoding data, falls in the range of approximately 3,100 to 3,200 BC. The precessional cycle requires 25,920 years for the equinoctial point to complete a full circuit of the zodiacal belt, meaning that the equinoctial point returns to the same position it occupied at network establishment after that full cycle has elapsed. The CBS tablets do not, according to the Bologna translation, specify that the opening conditions require a full precessional return. They specify a fractional return, designating the appropriate moment as when the great turning has advanced by 1 part in 6 from the position of the placing, a specification that identifies an interval of approximately 4,320 years after the network's establishment date, 4,320 years after approximately 3,100 BC falls in the range of the early 21st century AD. The text does not name a specific year. It describes a window within which the convergence of conditions would align, and the first of those conditions, the precessional astronomical marker, places that window in the historical moment the current generation of researchers inhabits. The technological conditions specified in the CBS opening protocols, the appearance of instruments of the sky that allow seeing into the Earth, is the element of the return protocol that has generated the most discussion among the small community of researchers familiar with the Bologna team's full translation. The Sumerian phrasing uses two specific compound terms for this condition: multuku kisal, meaning the sky instruments of the courtyard or outer domain, and kidubba, meaning the writing of the earth or the reading of what is below. Together these terms describe, in the vocabulary available to a Sumerian scribe, a technology that operates from the sky to produce a written record of what lies beneath the Earth's surface, a description that captures the essential function of synthetic aperture radar satellite imaging with an accuracy that is difficult to characterize as anything other than deliberate. The CBS tablets appear to specify the satellite remote sensing technology that confirmed 8 of their 12 coordinates as a necessary precondition for the opening of those sites, treating the development of that technology as a predictable milestone in human civilizational development, rather than as an unknowable future contingency. The third category of opening conditions relates to what the CBS text designates as the state of the black-headed people, the Sumerian term for humanity, and describes through a set of indicators that the Bologna translation renders as conditions of both achievement and endangerment. The achievement indicators encompass capabilities in mathematics, astronomy, and what the text terms the joining of distant knowing, a phrase that Dr. Spada interprets as referring to global communication networks. The endangerment indicators describe conditions that the text designates as the fire that comes from within the earth and the sky that changes its nature, descriptions that correspond, with allowances for the Sumerian scribal vocabulary's limitations in describing future technological and environmental phenomena, to nuclear weapons capability and anthropogenic climate change respectively. The opening protocol's specification of human endangerment, alongside human technological achievement as required convergence for the time of readiness, reflects an understanding of civilizational development that treats certain categories of crisis as necessary preconditions for the retrieval of preserved knowledge, as though the installation designers anticipated that humanity would require the knowledge contained in the ki-gal-pesh sites most urgently precisely when its own capabilities had brought it to the threshold of self-destruction. The 4 ki-gal-pesh coordinates that remain unconfirmed through current satellite imaging analysis represent not a failure of the CBS tablet system, but a map of the limits of existing technology and political access. The 3 submerged coordinates in the Persian Gulf Basin, the Sunda Shelf and the Black Sea Basin require marine archaeological survey capabilities at depths and in conditions that exceed the operational parameters of current underwater remote sensing programs. The technology to image subsurface structures beneath ocean sediment at depth of 30 to 70 meters below the sea floor exists in prototype form at several marine research institutions, including the Woods Hole Oceanographic Institution and the National Institute of Oceanography of India, but has not yet been applied systematically to these specific locations. The 4th unresolved coordinate beneath the Greenland ice sheet presents a different category of challenge entirely. Ice-penetrating radar technology capable of resolving constructed features at the depth indicated by the CBS coordinate has been deployed extensively in Antarctic and Greenland geophysical surveys, but the specific location indicated falls within a region of the Greenland ice sheet that has received minimal survey coverage and whose bedrock topography is known only at a resolution too coarse to detect a structure of the dimensions the CBS tablets describe. The technical path toward confirming the 3 submerged sites involves a convergence of marine survey technologies that is advancing rapidly but unevenly across the institutions best positioned to conduct the required work. The sub-bottom profiling technology required to image constructed features beneath ocean floor sediment operates on principles similar to ground-penetrating radar, but adapted for the acoustic rather than electromagnetic domain, using chirp sonar systems that emit controlled frequency sweeps capable of penetrating multiple meters of consolidated marine sediment while maintaining sufficient resolution to detect the geometric regularity of constructed chamber walls. The CHIRP sub-bottom profiler systems currently deployed by the Woods Hole research vessel Atlantis achieve penetration depths of up to 15 meters in typical marine sediment conditions, insufficient for the Persian Gulf and Sunda Shelf coordinate depths, but adequate for portions of the shallower Black Sea target. The development of lower-frequency parametric sonar systems, currently under active research at the Marham Center for Marine Environmental Sciences at the University of Bremen, promises penetration depths of 30 to 50 meters in consolidated carbonate sediments, which would place both the Persian Gulf and Sunda Shelf targets within reach of survey capability within approximately 5 to 10 years, if current development trajectories continue. The Black Sea coordinate presents the most immediately tractable detection challenge among the 3 submerged sites, and the political circumstances surrounding Black Sea marine archaeology make it potentially the most accessible as well. The Black Sea's unusual oceanographic characteristics, including its permanently anoxic deep water layer, that has preserved organic materials in extraordinary condition for thousands of years, have made it a priority target for underwater archaeological research since Dr. Ballard's discovery of preserved ancient shipwrecks in the deep basin in the late 1990s. The establishment of cooperative marine research relationships between Turkish, Bulgarian, Romanian, and Ukrainian scientific institutions has created an institutional framework for systematic Black Sea survey work that does not exist for the more politically complex Persian Gulf and Southeast Asian survey contexts. A targeted sub-bottom profiling survey of the CBS Black Sea coordinate location, conducted within the framework of the existing Black Sea Maritime Archaeology project, led by Dr. John Adams of the University of Southampton, would require the addition of a single survey station to a research program that already operates extensively in the relevant region. The question of whether that addition will be made depends less on technical feasibility than on whether the CBS research receives the mainstream archaeological recognition that would make the inclusion of CBS-targeted survey stations in funded research programs professionally viable for the researchers involved. The Greenland Coordinate's confirmation timeline is dependent on a single technological development rather than a combination of incremental improvements. The NASA Operation Icebridge Airborne Survey Program, which conducts ice-penetrating radar surveys of Greenland and Antarctic ice sheets for glaciological research purposes, achieves bedrock imaging resolution of approximately 100 meters in most survey configurations, insufficient to detect a constructed structure of the dimensions specified in the CBS tablets for the 12th site. The Croesus ultra-wideband snow radar system developed at the University of Kansas and deployed through Icebridge surveys achieves higher resolution in the upper ice column, but degrades at the depths required for the Greenland coordinate. The development of a higher resolution deep ice radar system capable of achieving 10-meter resolution at depths of 2 kilometers is currently an active research priority within the glaciological community for reasons entirely unrelated to archaeology, primarily driven by the need to characterize the basal conditions of the Greenland ice sheet for climate modeling purposes. When that system is developed and deployed, which current projections at the Alfred Wegener Institute suggest will occur within the next 15 to 20 years, the Greenland CBS coordinate will be surveyable for the first time. The 12th ki-gal-pesh site placed its detection threshold not at the limit of ancient technology, but at the limit of 21st century science, and it will wait, as it has waited for millennia, until the instruments of knowing are adequate to the task its designers set for them. The 12 ki-gal-pesh sites, taken together as a system rather than as individual archaeological anomalies, reveal a level of long-range planning and civilizational self-awareness that the conventional model of ancient human development does not accommodate. The construction of a network of sealed repositories distributed across multiple continents, encoded with a coordinate system requiring astronomical and mathematical knowledge beyond what mainstream history attributes to any known ancient civilization, maintained by hereditary guardians across generations, and designed to be opened only when specific technological and astronomical conditions were met, describes not a primitive culture performing religious rituals, but a sophisticated civilization making deliberate provision for its own legacy after what it understood to be an impending period of civilizational interruption. The CBS tablets and the 8 confirmed formations they describe constitute, in this reading, the most ambitious act of knowledge preservation in recorded history, a planned intervention across time rather than space, executed by a culture that understood with clarity that the knowledge it possessed would be lost in any ordinary transmission, and so encoded it in stone, buried beneath the earth, and left the key in the stars above for whoever would eventually build instruments capable of reading both. The identity of that culture, the intelligence behind the CBS coordinate system, and the ki-gal-pesh network, is the question that all the evidence examined in this investigation converges upon without yet fully answering. The Sumerian textual tradition from which the CBS tablets emerge attributes the foundational knowledge of Mesopotamian civilization to the Anunnaki, beings described in the administrative records of the departure period as having arrived with advanced capabilities, governed terrestrial affairs through a sophisticated hierarchical system, and withdrawn at a calculated moment while leaving behind both the sealed repositories and the human guardian institutions designed to maintain them. The E-series tablets from Eridu's deepest building level describe the preservation network as a deliberate product of the departure planning, a provision made by an intelligence that anticipated its own absence and acted to ensure that what it knew would survive the period of human independence that its departure would inaugurate. The CBS tablets are that intelligence's operational record, and the 8 confirmed formations are its physical legacy, waiting beneath the earth of 4 continents for the moment when what was placed inside them can finally be retrieved, what the CBS network requires us to accept if the 8 satellite confirmations and the textual evidence are taken together at their combined evidential weight, is that the conventional history of human intellectual development is incomplete in ways that matter fundamentally for understanding who we are and where we came from. The mathematical sophistication required to design the CBS coordinate system, the engineering capabilities required to construct the confirmed formations to the specifications that the SARE data reveals, the institutional planning required to maintain the Guardian network across the centuries of the Third Dynasty and Old Babylonian periods, and the cosmological foresight required to specify the opening conditions in terms of a precessional astronomical window and a satellite detection technology that would not be developed for more than 5,000 years. None of these capabilities belongs within the horizon of what our discipline currently attributes to the earliest periods of organized human civilization. Either the capabilities existed and the current historical framework must be revised to accommodate them, or the evidence is somehow wrong, all of it simultaneously, in ways that would require the most improbable coordinated set of coincidences in the history of archaeology. 8 confirmed formations, spanning 5 countries and 4 distinct geological environments, each occupying the precise coordinate position specified in a 17-fragment Sumerian tablet series that no one read correctly for 4 decades, argue decisively against the hypothesis of coincidence. The significance of what the ki-gal-pesh network implies extends beyond academic historical revision to encompass questions about the human future that the CBS opening protocol conditions make unavoidable. If the network was designed to be opened when humanity had achieved specific technological capabilities, while simultaneously facing specific categories of existential threat, and if the current era matches those conditions with the precision that the CBS text appears to describe, then what was placed inside the confirmed formations is not merely archaeologically interesting. It is potentially relevant to the challenges that the return protocol identifies as the trigger for access, the converging crises of technological capability and civilizational endangerment that the tablet's designers apparently anticipated with sufficient clarity to use as the opening conditions for a network established more than 5,000 years ago. What was preserved within the Great House of Keeping and its 11 companion installations, the records of calculation, the instruments of knowing, and the living patterns of the black-headed people sealed within their mineral vitrified containers, was not placed there for historians. It was placed there for a moment of civilizational need that the CBS tablet's authors believed would eventually come, and that the evidence now accumulating from 8 confirmed formations beneath the surface of the ancient world suggests may have arrived. The investigation that began with 17 clay fragments in a sealed ceramic vessel has arrived at a destination that the conventional history of human civilization has no prepared framework to receive. Across 8 confirmed subsurface formations spanning 5 countries, 4 geological environments, and a geographic range of more than 4,000 kilometers, the ki-gal-pesh network stands as physical evidence of a planning intelligence whose capabilities exceed anything that the standard narrative of ancient Mesopotamian civilization attributes to any institution or individual within the documented record. The CBS tablet series is not mythology. It is not religious imagination rendered in administrative language. It is an operational document, and the 8 formations that satellite imaging has now confirmed are the operations it documented. The convergence of evidence across the domains examined in this investigation is not the kind of convergence that coincidence produces. The astronomical precision of the coordinate encoding system, requiring spherical geometry corrections and a separated decoding key designed for institutional security across centuries, reflects mathematical capabilities that the conventional history of ancient science does not attribute to any Sumerian scribal tradition. The material density signatures of the confirmed formations reveal construction techniques and engineered composites that the documented archaeological record of ancient Mesopotamia does not contain. The Guardian bloodline system documented in the Nippur Eni series administrative records represents a multi-generational biological and institutional management program whose scale and continuity has no parallel in any other known ancient administrative tradition. The cross-cultural resonances in Egyptian Hermetic texts, Vedic cosmological literature, and Mesoamerican astronomical codices replicate the CBS network's 12-site framework across traditions with no documented contact, in terms specific enough to indicate shared knowledge of shared physical reality rather than parallel mythological invention, and the opening protocol conditions specified in the tablet's final section describe the astronomical and technological circumstances of the present era with a precision that transforms the CBS system from an archaeological curiosity into something considerably more immediate. What the totality of this evidence demands is a fundamental revision of the timeline of human intellectual development, one that locates the capabilities demonstrated by the ki-gal-pesh network, not within the gradual developmental arc that conventional archaeology traces from primitive agriculture through early urban civilization, but within a prior horizon of achievement whose extent and character the 8 confirmed formations are only beginning to reveal. The civilization that built the ki-gal-pesh network understood that what it knew was worth preserving across periods of loss so extended that ordinary institutional transmission could not bridge them. It understood that the instruments capable of detecting its legacy would not exist for thousands of years. It understood that the moment of retrieval would coincide with a moment of civilizational crisis severe enough to make the preserved knowledge necessary rather than merely interesting. We are that moment. The instruments of the sky that allow seeing into the earth have now confirmed 8 of the 12 sealed places. The 4 that remain await only the technology that each passing decade brings closer to operational capability. What was placed inside the Great House of Keeping and its 11 companion installations across the ancient world was not addressed to the past. It was addressed to us, to a civilization advanced enough to find it and endangered enough to need it, arriving at precisely the threshold that the CBS tablet's authors encoded in stone and astronomical cipher more than 5,000 years ago. The question that the evidence now places before us is not whether the ki-gal-pesh network is real. 8 satellite confirmations have answered that question. The question is whether we will pursue what the network contains before the window of civilizational readiness that its designers anticipated closes around us, and whether we possess, alongside the technological instruments required to open these sites, the wisdom that their builders judged necessary to receive what was placed inside them.